Hello, everyone. Hello, hello. Oh, thank you so much for the subscription. Rash-sama, o ka eりなさいませ, go shujin-sama. Welcome to the computer lab. Yay! Yippee! Exhibition-sama, tadaima, o ka eりなさいませ, go shujin-sama. Thank you so much. Subbing before streamer come back because I'm shy. Oh no! You subbed at the exact moment for a public call out. Oh, thank you so much for the subscription, Bobo-sama! O ka eりなさいませ, go shujin-sama! Welcome back, welcome back! The Grand Shark-sama! Let's see, I got bored-sama, Kon Midori! Little Sam, o ka eりなさいませ, go shujin-sama! Welcome to the computer lab! The RX-sama, o ka eりなさいませ, go shujin-sama! Welcome, welcome! The Grand Shark-sama! Exo Drifter! O ka eりなさいませ, go shujin-sama! Hello, green friend! Hello, hello! Oh, Exo Drifter, are you also in the green circle? Are you a green circle streamer? Yay. We love to see it. We love to see it. Hello, everyone. Oh, 1 second. I just realized, I updated my chat bubbles. And I just realized I need to set the timing back. 1 moment. Let me open up Streamlabs. Yeah, I was doing a little more futzing with my chat theme. And because of that, oh, where's the login button? Maybe I'm already logged in. All widgets? No. Hang on. Sorry. Wait 1 sec. Okay, here's the login. Login with Twitch. Because I was futzing with my chat theme again, chat box, I set the messages to disappear really quickly again. So I need to change that back to... Okay. Your chat should now be persistent for 2 minutes. Yay! Okay, that should be better. That should be better. Let me just go back now to... Okay, yay! Hope this works. Okay. Yay. Yeah, I have updated my chat theme a little bit. Last stream, if you were here up until now, my chat theme was Windows 2000, and it has gotten an upgrade to Windows XP to match with the rest of my layout. I feel like I didn't do the best job, like, 1-for-1 changing the theme, so it's still a little bit different, but I'm gonna be slowly updating my chat overlays and everything, so it's gonna be a little bit cleaner soon. But yes, hello everyone, welcome to the computer lab. If you haven't been here before, my name is Midori. I am your personal coding VTuber maid. I'm here to teach you all about programming, algorithms, TypeScript, Wiwa, whatever other languages we end up streaming in today. We're going to be doing a lot of fun stuff. Last week we just wrapped up the very first module in the LeetCode Explore track, which was arrays, and we're going to be moving on this week to chapter 2 of the Explore track, which is linked lists. Very exciting. Kind of for me the epitome of, like, not useless. It's not useless per se, but very coding 101. I don't think I have ever in my life used a linked list if I wasn't doing an algorithm question. But that's okay, because it's still fun exercises. What terrifies you? Don't be scared. Don't be scared, Goshujin-sama. Wiwa is really easy. No, it's a bit of a learning curve. I'm still learning it myself. We can all learn it together. Perhaps. But yes, thank you so much, everyone. I got some fun, exciting updates for everyone, but, let's see, I'll do my first, I'll do like the first exercise, and then I'll share some of my exciting life updates. Spoiler alert, they're cat related. I have some cat related life updates, which are very exciting. I might end up posting some cat pictures in the Discord a little bit later on and then sharing them here. But before that, I do want to jump in and get started because I fear that if I do not start coding soon, we will spend the entire stream yapping once again. I do want to fix, I feel like my lip sync is really off, so give me 1 second. We have to touch the code, it's true. I want to figure out why is my lip sync so bad right now? Can the cat program in Perl? We'll find out. We'll find out soon enough. Microphone. Webcam. What about that? Is that better? Oh, that does look better. Oh yeah, that's way better. Okay, great. Yay! Better lip sync. We love it. We love to see the better lip sync. Okay, let's move over and get with the program. Programming. Yay! All right, we are here. We are here in LeetCode land, and like I said, this week we're gonna start on linked lists. So I'm sure they'll say it in the introduction, but last week we were finishing up arrays, and arrays are basically like a big box that you can put stuff in. Hi Dre! Oh, thank you so much, Baron Sama. Thank you. I came prepared with water this time. So we can all stay hydrated. Oh, congrats on the watch streak, Baron Sama. Yay! I think you might be the first person that I've seen to get a watch streak, so thank you so much. I really appreciate your support. Concatenating lists. Yes. So arrays were basically like a box that you put things in. Linked list also is kind of similar to array. It's also like a list, but the difference between a linked list and an array is that in an array you can look up things by a specific position. Like you can say, find me the thing that's in like position 2, and you can look at your list and it'll come back with like everything or that you've stored in that position. But linked lists have a head and a tail. Instead of being able to look it up at a specific position, you kind of have to iterate through to get to the end. So we'll see in practice what that means. What else has a tail? I might have a tale of tales for you later. Stop posting links. Oh, wait. That's okay. How do I oh, here we go. I installed Nightbot, and I guess that moderates links now, but I can go ahead and repost it. It's okay, S-Vision Sama, sorry about that. I need to find out, like, if Nightbot bans someone. I need to figure out how to unban that. Cat language! Wait, that looks lovely. Cat programming language. It's a pure functional language. No variables, only instructions which manipulate a stack, and a special expression form called a quotation, which pushes an expression onto the stack. That's cute. Why is it called cat though? Is it because it's concatenation? I want this to be more cat themed. That's very cute though. Pearly functional. I love it. Oh, links are fine now. Thank you, Siki-sama. Thank you so much. I appreciate it. Yeah, you should all be able to post links in this house. Use the Kitty terminal right now. I've always thought about trying to switch to Kitty just purely for the name alone. iCat images in my computer. I appreciate this cat theming. I love it. I love it so much. All right, so let's dive into the introduction for linked lists, and we can get right into the first question, which I'm very excited for. Where did my music go? I'm having all kinds of... Oh, it's just a little quiet. Can you all hear the background music, by the way? Maybe right now is a bad time to ask that since it just got really quiet, but were you able to hear background music before? Let me know if you need it to be a little bit louder. I can make that happen. Yeah, the music should be good, so let me know if you can't hear it. I'll make it a little bit louder. Okay, yay, you're able to hear it. Good, 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 good. Okay, so introduction. In this card, we are going to introduce another data structure called linked list. Similar to the array, the linked list is also a linear data structure. Here is an example. As you can see, each element in the linked list is actually a separate object, while all the objects are linked together by the reference field in each element. There are two types of linked list, singly linked list and doubly linked list. The example above is a singly linked list, and here's an example of a doubly linked list. So the difference is that a singly linked list only goes in one direction, whereas the doubly linked list, you can actually go back and forth between them, which can be pretty useful sometimes. The difference is how many pointers, basically, how many references. So if you only have one reference field, you have the value and you have a reference that points to the next node, then that would be singly, but if it's doubly linked list, then each node has a value and then also like a before and after reference, so you can go in either which direction. We will introduce more in later chapters. After this card, you will understand the structure of singly linked lists and doubly linked lists. You will implement traversal, insertion, deletion in a singly or doubly linked list, analyze the complexity of different operations in a singly or doubly linked list, use two-pointer technique, fast pointer, slow pointer, in linked list. Okay, so we did that with arrays already, so we'll see how to use that in linked lists as well. You'll be able to solve classic problems such as reversing a linked list, and also analyze the complexity of the algorithms you designed and accumulate experience in designing and debugging. Yay! That sounds like so much fun. Alright, so we've got a couple sections to this chapter. Singly linked list, we got two-pointer technique, classic problems, doubly linked list, and a conclusion. So let's see how far we can get. I don't really want to stream for 6 hours again tonight, but it would be nice if I can get through an entire section. We'll see. Alright, so singly linked lists. As we mentioned in the overview, linked list is a linear data structure which link all these separated elements together by the reference field. There are two commonly used linked lists, singly linked list and doubly linked list. In this chapter, we will start with the singly linked list and help you understand the structure of the singly linked list, perform traversal, insertion, and deletion in a singly linked list, analyze the time complexity of different operations in the singly linked list. Okay. This is problematic because I want to do the problems, but what is... Oh no, they're all locked? Are they all locked? Oh! Wait, no. I thought only this one was locked. Are they all locked? Ooh, are we gonna have to subscribe? We have to look at the first problem just like, before we can look at the next one, just like a linked list. Well, it looks like there's supposed to be 3. So the way that I read this, complete previous. Okay. It does say complete previous. So we, whoa. Okay, we're okay. I was just clicking on the wrong thing. It is a linked list. Okay, good. Only the last one is paywall. That's good. Good news, everyone. Okay, so it looks like we have 3 chapters and then 1 problem. So let's go ahead and read through these. So introduction, singly linked list. Each node in a singly linked list contains not only the value but also a reference field to link to the next node. By this way, the singly linked list organizes all the nodes in a sequence. Here's an example of a singly linked list. So you can kind of see, like, in the diagram that they've written that each, like, element of the linked list is kind of a separate object, and then it has two fields. The two boxes represent, like, the different fields on the linked list node. So one field is just the value of that particular list, and then the next field is the pointer pointing to the next node. And that's true for all of them, and the very last one just points to null is how you know it's the tail end of the linked list. The blue arrow shows how nodes in a singly linked list are combined together. Node structure. Here is the typical definition of a node in a singly linked list. Okay, so last time everything was in Java for the examples, but now it looks like we can choose between Java and C++. That's pretty nice of them. Okay, so I'm gonna read it in Java, I guess, because it's a little bit more friendly for me than C++. So we have our singly list node class. It has a value, which is in this case an integer, although in theory, linked list could hold any kind of data type, but in this example, it's just holding an integer, I suppose. Then we have our next value as well, our next field, which in this case is another singly list node. So that's how you can see how this is all like strung together. Each node has a value, and then it has a pointer to the next node, which is another node with a value and a pointer. So it's a little bit recursive in that sense. It's not like truly recursive, but you see what I'm getting at here. And then the constructor takes a value int x and then returns value equals x to set that value. And I'm sure we'll see a little bit how we also set up like actually inserting a node. So in this case, we're just creating a node all by itself, which means that there is no next value, or it's not like linked to anything. But in this case, when we initialize the node, the next pointer would actually be undefined or null. But then I'm sure we'll see soon how you would link them together here real shortly. In most cases, we will use the head node to represent the whole list. So the very first node in the list is usually what we're going to be referring to whenever we want to refer to the entire list as a whole. So you start at the head and you move backwards usually, especially in a linked list, because in a singly linked list, there's no way to go backwards. So if you like referred to the list somewhere in the middle, there would be no way to get back to the beginning, because you only know what's in front of the node. You don't know what's behind it, for the most part. Okay, and then operations. Unlike the array, we are not able to access a random element in a single linked list in constant time. If we want to get the ith element, we have to traverse from the head node one by one, and it takes us O of n time on average to visit an element by index, where n is the length of the linked list. So hopefully, if you're following along, that makes a little bit of sense, because there's no pointer to any place in the middle by default. So if you want to get any node in the middle, you'll have to just keep paging through each node one by one till you get to the one that you're looking at. For example, in the example above, the head is node 23. Yeah, this one, node with value 23 is the head. The only way to visit the third node is to use the next field on the head node to get to the second node. And then with the next field of node 6, we are able to visit the third node. So you're only able to get from one to the other anywhere that there are these blue arrows. There's no blue arrow pointing directly to the third node, so therefore you would have to page through from the beginning to get there. You might wonder why the linked list is useful, though it has such bad performance compared to the array in accessing data by index. We will introduce the insert and delete operations in the next two articles, and you will realize the benefit of the linked list. After that, we provide an exercise for you to design your own singly linked list. Do any Go Shujin-sama in the chat have any ideas of why linked lists might be beneficial? Again, I have not really used this in practice, but there are some ways that the linked list is more efficient. So before we get there, let me know in the chat if you have ideas on where this could be useful, or in what ways it is more performant than a normal array. Okay, add operation for singly linked list. If we want to add a new value after a given node prev, that's not perv, even though I always read it like that in my head. You can insert something in the middle of a list. Jason Gross Sama, o kae ri nasai mase, go shujin sama, welcome to the computer lab. You are totally right. Why you would need that, I am not sure. Yeah, in practice, it's not like necessarily super useful, but it is much easier to insert into an linked list than an array, because if you remember, when we insert things into an array, we basically had to scooch everything over, so that took O of n time. But if you want to insert something into a linked list in the middle, as long as you have a pointer to where it goes, then you can do that in constant time. I guess that is constant time. Although to get the place where you're inserting in the middle, it would still be O of n time. So it's fine. Nukuno knows where to get the answer. Nukuno-sama, o kae ri nasai mase, go shujin-sama. What a rare sight to see Nukuno-sama joining me in my scheduled time. Linked lists allow cutting in the maid cafe line. Seems like cheating. Maybe it's because they have an advanced reservation. Maybe they're using their fast pass ticket to cut the line. Or it could just be nepotism. It could be favoritism. Okay, so if we want to add a new value after a given node previous, we should, number one, initialize a new node current with the given value. So here's the new node. Here's like our existing list, and then we make a new node. We link the next field of current to the previous next node next. So we're pointing from the new node that we just created. We're saying the very next one is going to be this guy right here. This is the next one. Now we kind of have two little blue arrows pointing to the same node. So all we got to do is move the previous node to point to the current value. So link the next field of current to previous next nodes next, and then link the next field in previous to current. Well, maybe it'll make a little bit more sense when we get to the code too, but this is a good illustration of what is going on with the pointers whenever we insert a new value in the middle of the list. Whenever a Go Shujin-sama is cutting in line, this is what happens with linked lists. Unlike an array, we don't need to move all the elements past the inserted element. Therefore, you can insert a new node into a linked list in constant time complexity if you have a reference to previous, which is very efficient. Again, to get to that previous, though, it does take O of n time. So, I don't know. To me, it's a little 6 of one, half dozen of the other. I'm not sure in practice if there are, like, areas of programming where this actually becomes very useful. You know, if you have examples, let me know in the chat, outside of just solving silly algorithm riddles. Alright, so let's look at an example. Let's insert a new value, 9, after the second node, 6. So we want to put it after 6, before 15. First, we initialize a new node with value of 9, then we link node 9 to node 15, and then link node 6 to node 9. So that is, after insertion, our linked list will look like this, and then we have a new train. Jason Sama says, I suppose linked lists can be useful for a double-ended queue implementation for some scenario where you might want to insert or pop from the front and back of an array. That's true, that's true. Because if you're, I mean, you still need to, like, keep a pointer to both the front and the back of the array, in order for that to be, like, super useful, but yeah, certainly you could do that, and that would be a very performant way of solving some problems. And I'm sure that there will be problems coming up where we have to do that. So we'll keep that in our back pocket. Okay. So that is adding a node in the middle, adding a node at the beginning. As we know, we use the head node head to represent the whole list. So it is essential to update head when adding a new node at the beginning of the list. So we start by initializing a new node. We link the new node to our original head node head and then assign current to be head. So in the example, when we add 9, so the previous head made of the linked list was 23, and then when our new head made node steps in, node with value number 9, we link it to point to the old head, and then we have to assign and specify keep track that is the current head of the line, basically. Wonderbread Sama says, the most common use case I've come across is tech interview questions for jobs where you'll never actually use them. True! Very true! By the way, Wonderbread Sama, o kaeri nasai mase, go shujin sama. If I didn't see you earlier, welcome in, welcome in. Well, you found a docs in Linux kernel talking about linked lists. Where was that? Now I'm very curious. Good day, good day! Kernel.org. Let's see. Linked lists. Linked list in Linux. Oh, interesting, interesting. Oh, the Lone Ranger sama, o kaeri nasai mase, go shujin sama, welcome to the computer lab. Is that an application or the LeetCode site? This is just the LeetCode website. We're just going through, different, here, I can link in the chat the chapter that we're working through. One moment. I have it linked on YouTube, but I should link it here too. Sigfault sama, o kaeri nasai mase, go shujin sama, welcome to the computer lab. Sigfault says, I used them legit once writing a network driver. The Intel Ethernet controller spec used them to configure the hardware receiver. Oh, that's really interesting. Wow. That's the first time I've ever heard of someone using them in the wild. That's very cool. That's very cool. Thank you. Oh, I love that. I love that. Let me, here we go. I will link this, linked list card. That is where we're working off of on LeetCode, and I can also show you, in, Explore, and then the LeetCode Beginner's Guide actually had, like, a really complete list of, Explorer cards that you can go through, so I can also link that here. This is the big list we are working through. Yeah, so we started with fun with arrays 101. We just wrapped that up last week, and we are just starting off on linked list. It looks like I'm basically following through this list here. So we've got arrays, linked list is the second chapter. After that, we'll do arrays and strings. Array and string. I don't really know how that's different from arrays 101, but I'm sure it's a little bit more advanced. hash tables, recursion, queue and stack, heap, and binary search. So I'm definitely gonna go through like one by one all of these sections so we can learn about algorithms together. And then once I finish that, I'll see how long it takes me to get through everything. I might go on to the second and third and fourth layers. I might do like all of these if we're really feeling ambitious. Or we might get bored of LeetCode at some point and switch over to, you know, some of the other suggestions that I saw in my suggestion box. Thank you again for your recommendations. But we took about like a month or a little bit more than a month to get through Arrays 101 because I am a bit of a yapper, as you'll find. I get sidetracked very easily, so we'll definitely be doing this for a good while. Oh, Luxar FPS, おかえりなさいませ, ご主人様, welcome to the computer lab. Welcome. Thank you so much for the follow. Dynamic programming, oh yeah, that's like at the very end. Dynamic programming, well, we'll see if we get there, we'll see. In the meantime, we're just working on a linked list though. So, adding a node at the beginning, you basically you link it so that its next is looking at the head, and then you just assign it to the head. Bobo is a fan of my yapping, yay! That's good, because I can't stop even if I wanted to. You're here for the yapping, or you're here not at all. Alright, so that is how you assign it to the head, and then what about adding a new node at the end of the list? Can we still use a similar strategy? What a cliffhanger, what do you all think? Do you think we can do it? Luxar FPS following for the awesome content and programming content as a fellow programmer. Oh, that's so cool, thank you so much, I'm glad you found me. What kind of programming do you do? What is your language of choice, and what kind of stuff do you make? Are you also do you also stream programming as well? Okay, they asked about adding it to the end. Can we still use a similar strategy? And then they don't go into it. So I have a feeling that that might be a problem we end up solving a little bit later. But definitely start thinking about how to answer that question. Okay, delete operation for a singly linked list. If we want to delete an existing node from the singly linked list, we can do it in 2 steps. First, we find the current, oh my gosh, they could have written this a little bit better. Find currents, previous node, previous. So whatever node we want to delete, we look at the one before it. And we look at the next node after it as well. We look at the previous one, we look at the next one. And then we take the pointer, the next pointer from the previous one, and we just skip over current over to the next one. So when you're iterating through the list, there's no longer any way to get to current without a direct pointer to it. In our first step, we need to find out previous and next. It is easy to find out next using the reference field of current. However, we have to traverse the linked list from head to node, from the head node to find out previous, which will take O of n time on average, where n is the length of the linked list. So the time complexity of deleting a node will be O of n. The space complexity is O of 1 because we only need constant space to store our pointers. So here's the example. If we have all these nodes and we're trying to delete the middle one, then we traverse the linked list from the head until we find the previous node, which is 23. And then we update the next pointer. Instead of being assigned the value of the 6th node, we assign it instead to like basically node 6.next, which is gonna bring us to node 15. And then node 6 is not in our singly linked list anymore. Let's see. Bobo-sama is learning programming right now as well. Oh, that's so cool. What led you to want to learn programming? Was it my streams? Did you stumble on my streams and say, I want to do that too? I'm joking. I'm sure that it's the other way around, but I like to think that I've encouraged people to learn programming already. Lexar doesn't stream it, sadly, but they are a software engineer who loves Java and C# mostly. Mostly work on backend with Spring Boot. Ooh, that's really cool. Spring Boot is like one of the most terrifying things to me in this world. I worked on like 1 or 2 Spring Boot projects in my time, and I could not wrap my head around it. It was like, I felt like there were so many magical things that you just had to know. And like, senior developers who were working on it with me would be like, oh yeah, you don't have to do all that. You can just like use this annotation and it does all those things. And I'm like, how did you know that? And they're like, you know. Arcane lore, exactly. Java is big on conventions. It's true, like Anime Expo. Is Java big at Anime Expo? Oh, watching along to streams does keep your brain focused to keep working on programming problems. That's so cool. Learning Python and C and love to use the shell to do things in Linux. Oh, great, 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 great. Yeah, I'm big Zish fan. I do love a good Zish shell for sure. The annotations save you, but I did spend so much time learning it. It's still scary to this day. I know. I hate all the annotations. It's like, it's like, it's not something that you can just go in. Like, a lot of languages, you can kind of go in and follow your nose through the code, even if you haven't used that particular language before. Like, usually you can be like, okay, that's a for loop. Okay, I get it. Like, that's doing that thing, and you can kind of follow through. But, like, Spring is like, you either know it or you don't. And if you don't know it, like, good luck. Good luck. Useful just for property handling. Oh, they also have some of the biggest conventions, 20,000 plus people. Yeah, that makes sense for Java. That does make sense. Oh, Jason Sama was saying about adding to the end of the list. You could use something like a standard vector. I don't know what the TypeScript. I don't know what the TypeScript equivalent is. Yeah, for a vector, well, a vector is like something that has 2 values, right? So I mean, for a vector in TypeScript, I would probably just use. None of you heard that. None of you heard that. Okay. I'm a TypeScript developer. Please take me very seriously. I'm a squipter who squips things. Okay, alright. Okay, so that's how you delete things from the middle. And then, if you want to delete the very first node, then you actually don't even need to, like, move the pointers. You just, move the head pointer to be the next one in the list. For deleting the very first node, it's even easier because there's nothing behind it that we need to link. We just say, oh, okay, this one's not the head anymore, this one's the head. And now, again, since it's a singly linked list and we only move forward, there's no way actually to get back to this 23 node anymore, so it has essentially been removed from the list at that point. What about deleting the last node? Can we still use a similar strategy? What do you think, Goshujin-sama? Can we use a similar strategy for deleting the last node? I'm sure that we will find out soon. Make sure that you use shell check on your scripts. Wait, is that a thing? I don't know what shell check is. Alright, we are on to our very first problem. And this, like, section actually only has one problem. So as long as I don't get way ahead of myself in the yapping department, I think we can get through. We can definitely get through more than one section tonight. We'll see. We'll see. Oh, shell check is a static analysis tool. That's very interesting. Shellcheck.net. Let's see. What do we got? Find bugs in your shell scripts. Ooh, that's very cool. That is very useful. That is super useful. Wonder if they have like VS Code plugins and stuff. I bet they do. They must. Alright, Go Suchin Sama, we are ready for our first challenge! Yay! Okay, so, design a linked list. Design your implementation of the linked list. You can choose to use a singly or doubly linked list. A node in a singly linked list should have two attributes, value and next. Value is the value of the current node, and next is a pointer or reference to the next node. If you want to use the doubly linked list, you will need one more attribute, previous, to indicate the previous node in the linked list. Assume that all nodes in the linked list are 0 indexed. Assume that all nodes in the linked list are 0 indexed. I'm not totally sure what they mean by that, but maybe we'll find out. Oh, I guess I understand. Like, if they're saying find the 5th node, then got it. I was a little confused because, like, on a array, like, it's not like arrays where you can say, like, pick out the 5th thing, but they might still tell us in a problem to find the 5th thing in the linked list. That makes sense. Just the normal way of list indexing. Yeah. Yeah, that makes sense. Oh, there were shell check plugins around for Vim and such way before VS Code even existed. It's been around for a while. That makes sense. That makes total sense. Yeah. I guess it makes sense that there are Vim plugins, huh? Of course there are. Also, it's written in Haskell. Very nice, very nice. I still need to learn me some Haskell. Alright, so, implementation, implement the my linked list class. We want to make sure that my linked list, initializes the object. We want to make sure that get, int index gets the value of the ith node in the linked list. If the index is invalid, return -1. I don't like that design choice because -1 could also be like, you know, assuming the value is just any integer. That's a little confusing, but okay. Okay, you love Haskell! Yay! Haskell lover! You should convince me to learn Haskell. Tell me what is so great about Haskell. Love me some C error quote-unquote types. Aw, yeah. Okay, add at head, should add a node of value val before the first element of the linked list. After the insertion, the new node will be the first node of the linked list. Add at tail, append a node of value val as the last element of the linked list. Add at index, add a node of value val before the ith node in the linked list. Okay, good to know, good to know. If index equals the length of the linked list, the node will be appended to the end of the linked list. Yeah, because it's 0 index, that makes sense. If index is greater than the length, the node will not be inserted. Okay. Delete at index deletes the ith node of the linked list if the index is valid. Alright. This is kind of a chonky. This is kind of a chonky one. I do almost want to like switch over. Morning Midori! New chat overlay! Welcome! Yeah, I didn't change too much about my overlay just yet, but I did change the chat boxes. I themed my chat boxes a little differently this time. I do have some new overlays on the way though. I've been working on it. I'm not a designer, but I'm doing my best. I'm trying to make it just a little bit cuter. It's still definitely gonna be Bliss themed, but we'll see. We'll see when I unveil it. I'm still working on it. Oh, Exodrifter is making a video about why they love Haskell. Oh my gosh, whenever you finish that, I don't know if you're in the Discord, but if you are, like, please drop that in the Discord. I would love to see it. If not, you can always come, like, to any of my streams and drop it there. You know, DM it to me, call me, beat me, whatever. I definitely want to see that video when it's done. Basically, it comes down to, it shows you a different perspective on how to think about programs. I love those kinds of programming languages. Haskell is functional, right? It's a functional programming language, I think. In particular about side effects and state, that I think really help you understand how to write better programs. Fine, you drive a hard bargain. I'll join the Discord where all the cuties hang out. Yay! Oh my gosh, wait, Siki-sama, did you set that up? Thank you, Siki-sama, I appreciate that. I got that command in about 2 seconds before you used it, Espicians. Thank you, everybody give a big round of applause to my beloved server admin. Could not do this without you, thank you. Yay, yay, yay! Clap, clap. Yippee. Okay. Alright, I'm gonna do a couple things before we dive into this. Number one, I'm gonna get myself a lozenge, because I've been talking more than usual the past few days, apparently. My voice feels a little gravelly. Then the second thing I'm gonna do, because this is like a little bit more complex, I'm thinking about open up VS Code for this, so that I can write like a little test suite for this as well. We can TDD this a little bit. Wonder Bread Sama, thank you so much for the hydrate. Alright, so what I'm gonna do is I am going to link this in the chat. Current problem. I will pin that. I'm going to BRB real quick and get a lozenge. And then we will get to it, Goshujin-sama. Thank you so much for your patience. One moment, please. All right, I am back. I have my lozenge. Is that like a Ricola? Yeah, it is. Like, it's like an off-brand Ricola. I think it's just called a cough drop. We have like the generic brand. And the first one that I picked out, I opened it up and there was only half a cough drop in there. Like, it's literally like clean cut in half. I don't know what happened. Very strange omen. Very strange omen. Alright, I'm gonna go ahead and open up VS Code. This is the first time we're moving over to VS Code, but this is a chunky enough problem. I want to set up a test suite. So let me file. What am I gonna need to do? Wonder Bread, sorry, I only wanted half. Rare product defect, sell out to Facebook Marketplace. Exactly. I could make a real profit there. Alright, let me open up my home/codes. Make directory. Does make directory work on Linux? Hopefully. Make directory, LeetCode. CD leak. Okay, cool. I didn't set up the code. Oh, I did! Yay! Amazing. Alright. I should be able to, put that in. If I do VS Code, share my window. Okay, and then I hide that and I show that, and I'm gonna need to resize it. Thank you for your patience, Go Shujin Saba. Sizing things in OBS is so finicky. Okay, and then just... Okay, hopefully that is good. That looks good. Alright, I'm gonna go ahead and switch it over. Okay! We are here in VS Code. Okay. I don't want to build this with an AI agent. VS Code. Okay, let's make a new file. We'll call it linkedlist.ts. And then let's make a new file called linkedlist.test.ts. And create a new terminal. Okay, and then let's npm. Oh right, we never installed npm, huh? pnpm, and then what kind of LeetCode do you think we're doing here, Wonderbreads? That we need a mono repo set up for our linked list and its associated test file. Alright, let me, still a little new to Ubuntu, so, npm. I'm just gonna use npm because it's what I'm used to. I know, like, people, pnpm isn't just for mono repos. I mean, I guess. I've only ever used it for mono repos, though. It's the least bad of the npm tools. Why do you think that, Wonderbreads? Justify your opinion to me. PNPM is faster, it saves space by deduping node modules. It's less likely to get supply chain attacked because of configurable package age policy. Okay, okay, okay. Workspaces are nice too. That's fair, that's fair. I'm just gonna use NPM for now because it's what I'm used to, and that's kind of besides the point of the exercise at this point, but no, that's valid, that's valid. Let me just pin this version. Okay, okay. So we have npm init. Okay, and then we can npm install jest. This is currently just setting up a really lightweight testing environment so we can write some tests and TDD our way through it. Spoiler alert, I might be doing a whole stream on TDD in collaboration with a certain tech VTuber who may or may not be in this chat right now. Not V-test? Alright, come on guys! A certain one? Yes, a certain one. I am currently planning a collaboration with another tech VTuber who started streaming at around the same time that I did. So we're still in the planning stages of that. It'll be announced in a little while once we have more details nailed down, but definitely look forward to that. I'm also very open to collaborations, by the way, if there's any other streamers or YouTubers in the chat and you have anything you would want to collaborate on, I'm super open to that. No, I'm not using VTest right now because, well, do you even really, because VTest is for Vite, is it not? That's like what I know it in the context of. Like when you're writing like a Vite application, you would usually use VTest. Not anymore? Oh, it has escaped containment. Well, I'm just gonna use just because it's what I'm used to. Just a nice ES build test runner. Okay, okay, okay. Well, I'll keep it in mind. I'll keep it in mind. Faster than just and no other dependencies. Alright, well, I'm still gonna do it in jest, but you can always use your channel points and force me to use VTest or whatever else, whatever other tooling you would like to force me to use. But fair warning, if you force me to use it, then you also have to teach me how to use it. I slightly joke, I slightly joke. As a neutral party, you don't have opinions, but it's interesting to see NPM, JS, and TypeScript things. Your channel points are for hydrate only. I appreciate that. I appreciate that. We do all need to be reminded to hydrate from time to time. For sure. Alright, so we've got Jest installed. Now let's see if we can, whoops. Oh. Control K M? No. I don't know why it doesn't know that this is jest. Do we need to do more jest setup stuff? Just install docs. Getting started. Oh, language request. Okay, Siki-sama, what are we doing? What are we doing, Siki-sama? NPM plus Bower plus Gold slash Grunt plus Sass plus Post CSS plus Babel plus Webpack plus Browser Sync plus ESLint slash JS Hint plus Jasmine! Siki-sama, I need to know if you're serious, because if you are, this is going to derail, like, the entire stream. And I mean, I'll do it for you. I'll do it for you if that's really what you want me to do. But you do have the option to change your mind. You do have time to change your minds. Here I was trying to help. And Backbone! Is this better or worse than French? Siki-sama, I'm gonna be so for real with you. I just straight up don't want to do that. I just straight up don't want to do that. Do I really have to do that? I mean, like, streamer's honor, I guess I do kind of have to, but, like, I'm having a hard time even understanding how to apply that to the problem at hand, which is, need I remind you, Vite is French. Need I remind you, the problem at hand is building a linked list implementation. That's all. That's all. I'm really having a hard time how we're gonna, like, fit in, like, half of those technologies. Okay, for one thing, that request is, like, way more than a single language request. That is a lot more. SAS, the Single Action Shooting Society, the home of cowboy action shooting. It's all JavaScript. I mean, if your language request is JavaScript, then I've got great news for you, buddy. I'm just gonna take that as a language request to do this in JavaScript and carry on with my day. Oh no. Oh no. See? I mean, that I can do. That I can do. It's gonna be a bit of a learning curve, because I don't think I've done... I may not have ever done any C. But I can if you want to. I gotta look into, like, test runners for C. I can do C. Yeah, we can do that. I'm game. I'm game. I do need a little bit of help, though, like, getting this set up, because I still want to, write some tests. So how does that work? How does that work? I'll just delete all of this. I'll delete all of this. We'll do it in C. We'll do it in C. My dreams of doing more than one question tonight are slowly dwindling. Do new language requests supersede the previous ones? To a reasonable extent, yes. I would say if I'm, like, halfway through solving a problem in a certain language, then I'll go ahead and like, finish the first one before I do the next one. They supersede them if the first request was stupid. If the first request was a dumb request, then yes, it supersedes it. Nano does the job? Are we doing it in Nano, everyone? Are we gonna be a Chad Nano developer here? You just have a compiler and then using Notepad. If I can do JavaScript and TypeScript, then I might have an easy time with C. Okay, okay. Yeah, we'll try it. I would really like to be able to continue to use VS Code for now, though, since that's like, it would be a lot. It would be a lot to do everything in Notepad. Everything in, I'm gonna do it in VS Code unless, forced to at gunpoint. I know, I'm trying to move away from VS Code, alright? But, like, I can do C in VS Code, or I can do TypeScript in, like, Vim. But I'm not doing, like, Amy uses Notepad++. Create a new .c file. Okay, that I can do. Okay, so linked list.c. And then, is there like a test runner for C code that I can install? Or is the test file also just gonna be like a C file? Let's see, C test runner. Write a test runner in Rust? That's gonna be, writing a test runner in Rust, I feel like that's gonna be, a lot more channel points than just a language redeem. Oh, Kwang-sama had a setup for a test runner in C, except it runs on Bash. And requires another 2 files. I typically use the build system for running tests. Okay. I mean, Kwang, I'm not opposed to trying to use your test runner, but it would have to go through, what is it, compliance with my, server admin. If it passes compliance, then, I will certainly use your tool. C test runners. We got, okay, let me switch over to GitHub real quick. Window scene, get Firefox back. I'm just glad I'm not the one that derailed this evening. I know, and think you guys are like getting yourselves further and further away from cat talk, by the way, because I'm not talking about the cat news until after I finish this problem. I was gonna bang this out quick so I could yap, but you all said no. Oh, why is my by the way, why is my browser looking like this? My browser's looking a little bit funky. Okay, that's fine. That's fine. I can use cat in the terminal. She is 16. The cat is 16. That's true. But that is spoilers. That is spoilers. The cat is 16. I am not 16. As has been stated many times, my age is actually formally pronounced as dial-up sounds. That is how old I am, but it is not 16. But the cat is. Okay, Okay, test is a little overkill for LeetCode problems. True, true, true. Okay, well, if we're gonna do C, then I guess I'll just do it in, I won't TDD it, and I'll just do it in here. Whoops. Meant to do... Alright. Type def, struct my linked list. My linked list create. Okay, so this is like the constructor. This is clearly like this is the struct, this is the constructor, and then these are the functions that we're going to be writing. Yay, pointers! Okay, so, I guess I'm gonna have to pull up, like, C documentation. And anybody in here who knows C, you're gonna have to help me out. Struct declaration? That sounds like what I'm looking for. Anyone want to take bets on how many hours this is gonna take me? Siki-sama, why did you even want me to do C? I never hear you talking about C. The C in Maid Midori stands for C programmer, exactly. Wonderbread-sama, how do you envision this working? Because technically, if we're building a linked list, you're just saying we can't use, like, linked lists. Like, we can't use an already created linked list data structure to create a linked list. So, like, I feel like we already weren't going to use linked lists in this implementation. It's banned in the output, too. Alright, Wonderbreads, I do not know how to help you with that request. You are welcome to request something in its place, if you prefer. I don't know how to honor no linked lists when I am quite literally building a linked list. I don't think I can do that. I don't think I can do that one for you, boss. Okay, well, without documentation, this is going to be much more difficult. Let me see. C struct W3 schools, you have never failed me. Grind for 30,000 points so you can send me to an IOI problem? Wait, what is IOI? We can temporarily ban Siki. Sorry, Siki-sama. I don't make the rules. Alright, I feel like it's fair to say that Siki-sama can't help me with this. Siki-sama is banned from helping me, with this problem. Which means that all the rest of you are gonna have to step up here, alright? Okay, create a struct, like this. Okay, so int my num, okay. We're off to a great start. We are off to a great start here. So, we want to do that. So, int, we wanted it to be, what, val? Val. Okay. I feel like I already hacked this up. Type def struct. We don't even know which version of C LeetCode uses. Learn more about our C environment. This is a very long... Alright. Hydrate! Thank you so much, Wonder Bread Sama! I'm gonna run out of water here soon. I'm gonna have to get more water. GCT 14. You are helping. You are helping. It's true. It's true. Okay. Let's continue. Let's continue. I currently have one thingy. Can we get 2 thingies? Good. Suki-sama is honoring the ban. I appreciate that. Okay, so we have our int val, and then, can I do, like, my linked list, next? I can do that, right? Should work, should work. Hopefully, hopefully. Is this not how pointers work? I was hoping that this is how it would work, but, maybe it's not. Does it have to be, like, a pointer to my linked list? Oh, I have to declare it as a pointer. Okay. My struct is currently of infinite size. Good. That's great. Okay, creating pointers with the reference operator. Oh, pointer variable. Okay, so we gotta add a star. We gotta add a star. Just like this. Just like this. My linked list create returns a pointer to a my linked list. So next is a pointer. Did I do it? Am I doing it? Am I doing it, chat? Am I doing this? This isn't so bad. I'm learning! I'm learning! Okay. Hopefully this is good. Looks good. LGTM, thank you. Thank you for your sign off. Sigfault Sama, thank you for your PR review. Alright, so we have our struct. We're already halfway there, right? We got our struct, everything follows from that. Okay, we need to define the constructor. The constructor, can I like control command F for constructor? No, of course we can't. Of course we can't. Let's go back here. My linked list create. Oh, this is just gonna create. Okay, so what is comments, by the way? Is it / like that? That looks right. Okay, so first we need to create a new node. Return the node. Okay. Got it. Yeah, C doesn't have constructors. This is just a method to create a struct type. Got it. Okay, cool. Yeah, the comments is the same as JavaScript. That's very convenient. Okay, so we're gonna create a new node. In order to do that, let's go back. Let's look for structs. Is a struct the same as a structure? Struct, yes, okay. Struct, my structure, S1. Create a struct variable with the name S1. Okay. So So are we gonna do like struct my linked list and call it head? Is that valid C? I'm doing like what I see here. A skull emoji? Does that mean I'm doing it wrong? I don't need it because I typedefed it. Struct my structure. Typedef struct. I see. Because typedef. I see. Okay, so we just do my linked list head. Siki-sama, that's a really good point. Okay, we're making progress. And then we want to assign the value, my linked list create. Okay, one interesting thing. Okay, I'm a little bit confused, you guys. Like, just in general. Because it says, my linked list create. We're creating a new linked list. But... it should be an empty linked list with no... node? Maybe... okay, so we have my linked list. Maybe we also need to make, like, a node struct. Does that seem reasonable? So the, this is actually gonna be our node. And then typedef struct. And then the my linked list is going to have a my linked list head. It seems like it wants a weird interface where the start of the list is not a node. Yeah. Sorry. Yes, exactly. So, oops, sorry. This is gonna be a node. So my linked list is gonna be, the my linked list struct just has a head, and the node struct has the value and the next pointer. The other one is also a node. Yep, you are correct. Okay, this should be in order now. And then to create a new linked list, we're going to create my linked list called list. And I think if we do this by default, head will be null, right? Which is what we want. So I think then we can just return. Do we just do return my linked list? Is that fine? Is that fine? Return, yep, return, yeah. List. Return list. Yep. Okay, good. Node head. I can do dot head equal to null. Okay. If I want to be explicit, sure. Would it be equals dot head equal null, just like that. Is this working? This kind of feels like Twitch writes C. Twitch writes C. Okay. I'm trusting all of you to tell me if this doesn't look right. Okay, so that is to create a new list. I underestimated about making a linked list in pure C. Return and list, but I don't know if a local variable will live past the function. May need malloc. Okay. I do remember doing head next in C++. Okay, what is the ampersand? Type def. Oh, this is what we're doing, huh? Type def. Int main. Okay. Malloc. Is this memory management? Yeah, yes, okay. We're in the right place. Let's see. When you create a basic variable, C will automatically reserve space for that variable. An int variable will typically occupy 4 bytes of memory, while a double will occupy 8. You can use the size of operator to find the size of different types. Ampersand var returns the address of var, which can be assigned to a pointer, if I recall correctly. Okay, let's see. Allocate memory. That sounds like malloc. Memory allocate. C structs and memory. Okay, let's see. You can also use dynamic memory with structures. This is useful when you don't know how many structs you'll need in advance, or you want to save memory by only allocating what's necessary. You can use the malloc function to allocate memory for a struct pointer. Okay, so we've got our car struct, and then in main, struct car star pointer. Struct car star malloc size of struct car. Oh my god, I'm so lost. Let's see. Malloc returns void, so you have to typecast it. Is this the typecasting? Is this what typecasts it? In the parens. Okay, so we're typecasting malloc to a pointer to a car. And then malloc size of struct car. And what the hell is the star next to the, does it have to be star list because it's a pointer to a list? Is that what's going on? Star is for pointer types? It's the wrong way to format pointer types. Okay. I'm gonna just read through memory management real quick. Do the crash course, okay? How hard could it be? Process of reserving memory is called allocation. The way to allocate memory depends on the type of memory. So he has two types of memory, static memory and dynamic memory. Static memory is memory that is reserved for variables before the program runs. Allocation of static memory is also known as compile time memory allocation. C automatically allocates memory for every variable when the program is compiled. For example, if you create an integer array of 20 students, C will reserve space for 20 elements, which is typically 80 bytes of memory. Okay. But when the semester starts, it turns out that only 12 students are attending, then you have wasted space of 8 unused elements. Since you are not able to change the size of the array, you are left with unnecessary reserved memory. Note that the program will still run, but it's not damaged in any way, but if your program contains a lot of this kind of code, it may run slower than it optimally could. If you want better control of allocated memory, take a look at dynamic memory below. Dynamic memory is memory that is allocated after the program starts running. Allocation of dynamic memory can also be referred to as runtime memory allocation. Unlike with static memory, you have full control over how much memory is being used at any time. You write code to determine how much memory you need to allocate it. Dynamic memory does not belong to a variable, it can only be accessed with pointers. Okay, that seems like probably what we need. This isn't really correct. Stack space is allocated at runtime too. Okay, interesting. How hard could it be? Literally why Rust was made. Welcome to the real world, Neo. Okay. To allocate dynamic memory, you can use the malloc or calloc functions. It is necessary to include the standard lib.h header to use them. The malloc and calloc functions allocate some memory and return a pointer to its address. Okay, so pointer 1 equals malloc, size. Pointer 2 equals calloc, amount and size. So malloc has one parameter which specifies how much memory to allocate measured in bytes. Calloc function has two parameters, specifies the amount of items to allocate and then the size of each item measured in bytes. Okay. The best way to allocate the right amount of memory for a data type is to use the size. Oh, I see. Size of. Okay. Got it. So we're gonna do something like this. Calloc is like if you're doing an array, so you don't gotta math it yourself. That makes sense. Okay, so let's start with malloc then. So we'll do something like this. Be careful. Size of pointer 1. Tell C to measure the size of the data at the address. If you forget the star and write size of pointer 1, instead it will measure the size of the pointer itself, which is the usually 8 bits that are needed to store a memory address. Okay. Wait, I'm confused by this example, because this is like self-referential. We're like instantiating pointer 1 and pointer 2 to be ints. Oh, this is probably instead of the typecasting, right? So we could do like, let me... Oops. My linked list, so we would go like this, and then, wait, is it any different? Is malloc any different from just doing this, though? And defining it as null? Is it actually any different? Oh, I see. This won't allocate any space for the value. I see. Okay, then let me do this, and then we can do this. list equals malloc size of star list, right? And then return the pointer to the list? Is that right? Or do we return the whole list? No, we must return the pointer to the list because it says it returns a pointer. Oh, it's already a pointer type. Okay. Alright. Let me add comments here. Already a pointer. Create the list pointer variable. Allocate memory for the values. Can I then also like list dot head equal null or something like that? I can do that. Okay. Sure. Explicitly set head to null. Okay, S-Vision-sama is giving me an alternative syntax. But honestly, I'm just gonna try and get through it. Alright, arrow it probs? Wait, why? List.head or list arrowhead. Oh, I see. I gotta do, okay. List arrow. Like that? Or does it have to be the actual arrow, symbol? I want to wait for 10 minutes and she's already making a progress that I did in 2 weeks. It's all because of my helpful Go Shujin-sama. Twitch makes it into an arrow symbol. Okay. See, it was invented before Unicode. Oh my gosh, I was working with an intern the other day, and what was it that we were talking about? We were talking about how right, we were using Sequelize in our project, which is a relatively older ORM at this point. I was like, oh yeah, he's like, oh, I'm surprised that Sequelize doesn't have like TypeScript support built in. And I was like, oh yeah, well there's plugins, but you know, Sequelize is older than TypeScript. And he went, older than TypeScript? Sequelize is older than TypeScript? He like couldn't believe it. I've never felt older. I've never felt older in my entire life. Look up trigraphs. Dash greater. Okay, trigraphs. What? Why? Oh, yo. Okaeri nasai mase. Piña de manzana? Piña de manzana man. Okaeri nasai mase, Go Shujin-sama. Welcome to the computer lab. My Go Shujin-sama chat is currently forcing me to learn C. Look up trigraphs in C specifically. Oh no, the forbidden knowledge. I'm gonna try and stay at the task at hand. You guys have given me a chonky enough task that I'm gonna give it my best. Oh, thank you so much for the follow. Thank you, Stack Del Diaz. Stack de Ideas. Stack de Ideas sama. Okaeri nasai mase, Go Shujin-sama. Welcome to the computer lab. Nihongo? Yes, I'm very Nihongo Jozu. I speak Nihongo at a 2-year-old level, but have learned the various maid cafe phrases so that I can be a proper coding maid here in my computer lab in the mansion. Alright, I'm gonna forge ahead. I think this looks like it might run. So I'm just gonna keep going and see where it goes. Basically N1 level then. True. So true. If you ask any Japanese person that I've interacted with while I was there, they will tell you that I am practically N1 Nihongo Jozu. Extremely true. Is there a LeetCode for Nihongo? There should be. There should be. For me, the equivalent is probably like, well, my equivalent is probably like WaniKani, which I do try and do every day, but I've been a little lazy about it lately. I do have to apologize. Don't even have my N3 score yet. Yeah, me neither. I took the N4, like a year or two ago, and I like barely squeaked by. I did technically pass the N4 by like a couple of points. Oh, you need to pick my brain about this. Yeah, Nukuno, let's talk about the Nihongos for sure. I'll get you hooked on WaniKani. It's pretty fun. Would LeetCode for Nihongo be neat code? That's very good. That's very good. I like that. At coder.jp. Is that like Japanese LeetCode? At coder. Ooh. At Coder Beginner Contest Nihonbashi Half Marathon. Interesting. Very interesting. This will require more research. Broke my ban for that. I want a refund. Japanese code forces before code forces. Interesting. Neatcode.io is an actual thing, but is not run by a Japanese guy. A better way to prepare. Wow, this is really funny. Okay, I gotta do Neatcode next. Once we get through at least like the first layer of Explore cards, we definitely have to try Neatcode after this. Okay, I'm gonna move along to getting a linked list item. So int my linked list get, it takes object my linked list, and then it takes an index. So I gotta look up for loops in C. For loop, C for loop. For expression. Okay, this is pretty similar. Okay. Int I. Okay. Sum of numbers. Int I. Okay. Let's copy this over. Let's copy this over. Okay, for int I. For I equals 0. I... oh, no. We're gonna do a while, right? No. While I is less than index. While I is less than index, I++. In this case, the index is gonna be 0 indexed. So we want to do I less than or equal to, probably. Maybe there's a off by 1 error there, but we will get back to that. And then, for each thing, what we want to do is, let's create a pointer to a, node star, what are we gonna call it? I guess I'll just call it pointer for now. Oh wait, is it the other way around? Is it, node star pointer? They're the same? That's some bullshit right there. Okay, I'm just gonna do that because it's what I did up here. So we'll make a pointer to a node, and then, I want that node to be the head. So can I do like node star pointer equals object dot head, or does it have to be head like that? I am this is vibe coding before AI. This is what vibe coding was before AI. I'm literally just writing down things and UC list arrowhead, that's exactly how you remember writing linked lists in C++. It's behind a pointer, so arrow. Okay. I can also do node star pointer, like the star with a space in between. That's okay. The chat is agents. Exactly. Okay, I'm breaking my own no vibe coding rule, apparently. But you guys are more intelligent than an AI, right? That could be like a TV show. Are you smarter than like, instead of are you smarter than a 5-year-old or a 5th grader? Are you smarter than an AI? Agent of chaos, exactly. Will I be implementing a code style checker to enforce one of those as part of this exercise, Vision-sama? No. No, I will not. Stretch! Oh my god, Siki-sama, good idea. Oh, we're gonna do a big stretch. Ugh. Is that because our cat just did a big stretch? The cat that you guys are never gonna find out about because I'm gonna be stuck doing this C bullshit for the rest of my life. AI being smarter than chat is a stretch. Alright. I'm not gonna do, I don't feel like I deserve a full stand up and stretch, but I have done a good little stretch here. What is the cat's name C? Oh, you could really do some wacky syntax with arrays in C? Oh boy. Okay, so we're going through the list. We have our pointer, which starts by pointing to the head of the linked list, and then for each I, starting at 0, we're going to pointer equals pointer dot next. I'll call this, instead of pointer, I'll call it current node. By the way, is camel case, or in this case, yeah, it's still camel case. Is camel case like the norm for C, by the way? I hope it is. Oh, and it's gonna be arrow, not next. Current node next. You just do camel case? Okay. That's good. Okay, so then we have the current node, and then we can return current node val. Hopefully? Or is it dot val because it's not a reference, it's the actual value? Current node is still a pointer, so arrow. Okay. The norm in C is omitting every other letter from the variable names. Single letter variables is the norm. Okay, hopefully that does the thing. Praying that it does the thing. A little out of topic JP question. What is, sore, is that chigau? Can I read? I can only read a little bit of kanji. That looks like chigau to me, I think. Something, naka, so, oh, sure, not sore, sure. Sure chigau. Sure chigatta hito. Oh. Katoe-san, konbanwa. Okaeri nasai mase, go shujin sama. Maid-sama, as I should say. Welcome to the computer lab. You finished resoldering your keyboard. Yay! Oh my god! That sounds like a big task. Did you have to solder like every single switch on the keyboard? That sounds like quite an adventure. Hot swappable. Wait, it was hot swappable before? Wait, did you hot swap the key switches, or did you solder them? Oh, according to Yomitan, Surechigawa means to pass by each other. Oh, interesting. So... Surechigata hito, like the person I passed by? Oh, you replaced your old switches and made them hot swappable. That is super cool. You know that I've been wanting to do that project on my keyboard too. Maybe someday we can do a collab stream. We can do a soldering stream. Thanks to hot swappable, you only lost 2 switches when you spilled matcha on your keyboard. That's on me. I'm the one who turned him onto matcha lattes. Lead. LeetCode, how fun! Let's see, KNVSFX, I'm just gonna call you FX-sama. FX-sama, o kaeri na sai mase, go shujin sama, welcome to the computer lab. Yeah, we're building a linked list implementation, and my chat is currently forcing me at gunpoint to do it in C, which I have never coded a line of C before in my life. I think I did like a quarter of C++ in community college, like years and years ago, maybe? I don't like lead-free solder, it doesn't smell as good. No TDD, but there's the case if index is greater than size, return -1. Oh, yeah. So first we gotta check that, huh? So we gotta check, I'm hoping that it's a similar syntax here. If, oh, we don't know the size, so what we have to do is, oh, right, what happens if we call, we gotta first check, if current node next equals null, right? We gotta do something. Return -1. I think that's what we want to do, right? FX-sama, I mean, it shouldn't be too much different. That's what I said, and yeah, here we are. What if an empty list gets passed in, though? I guess we do if that or, like, we want to check both cases. I guess we can just check first. If, object is null, then return -1. Probably. All it takes is 20 lines of C code and something goes wrong for no reason. Well, I haven't run it yet, so we'll see. We'll see. You have to reprogram your keyboard in C. What keyboard are you using? How old is this keyboard? You can't just use, now I'm forgetting the software that I usually use to flash my keyboard. Ah, driver development. Keyboard, flash, open, source. What is it that I use? QMK? QMK... QMK is C? Oh boy. Chat, last stream about C foreshadowed this. I guess me putting my blood type as C foreshadowed this. Okay, so let's see. So I'm checking, first if object is null, then return -1. Then otherwise, we loop over we start with current node at the head, and then we check if the next node is null, then we return -1. Otherwise, we set current node to be current node next. I'm so glad Via exists. Yeah, Via is what I normally use. I think Kazuki-sama taught me about it. Via makes it very easy. No real programming required. Is the cat named Via? These are all very good cat names. There's still a bug there, but that's good enough for now. All right, we'll see what the bug is when we run it. I'm gonna just like go based on vibes, and then we'll kind of like debug our way through it. Okay, and then adding at ahead. So we need to create the node first and foremost. So we create node. Hydrate, yay! Raspberry Val-sama, o kaeri nasai mase, go shujin sama, C++. No, this is C. This is just straight up C. And it's my first time ever writing any C, so we are doing our best here. Might be useful to make a create node function. C minus. Yeah, we could, but I feel like creating a node hopefully isn't too much work. We'll see. So node, new node. No, new node. Ooh, we're 75% of the way to my follower goal. What was my follower goal again? 256, I think? Oh, I'm missing some semicolons. I'm too used to JavaScript, man. I'm too used to JavaScript. Strings are awful to work with in C. Pambu-sama, welcome in. O kaeri nasai mase, go shujin-sama, welcome to the computer lab. Okay, so we're gonna create our node. New node is going to be val is val equals val? Yeah? Or is it like that? I think it's like that, right? Val equals val. Oh, dot val. We gotta do dot val. Dot val equals val, hopefully. Dot val equals val. Okay. Watch debugging this when you forget free, unless does this matter in LeetCode? In LeetCode, is anyone truly free? Is this a new chat style? I see. Yes, it is. Yes, it is, Pembu-sama. Very good eye. Since last stream, I decided to update my chat styling to Windows XP from Windows 2000, so it matches a little bit better with the rest of my stuff. I didn't get the border rounding quite right, but it's good enough for designed by developers work. In both C and LeetCode, no one is free. That's very true. Do I have the list length beforehand? No, I don't believe that we're given the list length. So if we ever need to find out how long the list is, then we will need to count that ourselves. That's why in the get function, I'm not checking up front if the index is outside of range. Instead, we kind of like figure out as we go along whether we've gone out of bounds by checking if the next thing is null. Go walk the list, pal. Exactly. Line 42 has a bug. Node star new node equals, is it the lack of semicolon? Something's wrong with the dot val, isn't it just val equal to val? Since you already, unless object.val or something in the right expression. Well, we want to make the new node like a brand new node with the value equal to the val that's passed in. And if we're adding, we're also, I have no idea, is it a semicolon dot next equals object like that, maybe? It's a comma? Okay. I have no idea if this syntax is right, but no, I'm creating an object on the stack and assigning a pointer with the value on the stack. Okay, hopefully this is right, but we'll see, Malloc first, object needs to live past the function. Okay, so instead new node is going to be, where was the Malloc? Malloc size of node. Okay, so new node equals Malloc size of node. Is that right? Does that look like what I did before? Star list. Oh yeah, we gotta do star node. Those can be a single line? Amazing. Just like that. No star. Wait, really? Are you sure? Size of variable or size of... Oh, I see. Okay. Oh, right. Because here we were looking at size of... No. You want to allocate value for the object itself, not the pointer to the object. No idea on syntax change language? No, I'm committed. I'm committed to this. I am so committed to this. You want to allocate the value for the object, not the pointer to the object. Both are equivalent and correct. Wow, I love C programming language. Did you change? I left for a while. Yeah, some, Sidki-sama actually, redeemed the language request and said that I have to do it in C. I guess we do C now. This is what happens when I haven't programmed C in like 2 years. Yeah, so, Sidki-sama cashed in a language request for C, and then was it Wonderbreads who cashed in requesting to ban a language or concept or construct and decided to ban Sidki-sama? So Sidki-sama, who requested I do it in C, is not allowed to help me do it in C. Think about pointers as big integers with additional logic on top of it. Yeah, okay. Size of star list looks at the type that list points to. Size of type uses the type directly. My blood type is C after all. I can definitely do this. Yes, I definitely can. We're gonna get through it, chat. Node star is an integer, node is a struct instance. Okay, that makes sense. Ooh, it's Divyansh Kiran. I'm gonna say Kiran-sama, o kaeりなさいませ, go shujin-sama. Welcome to the computer lab. Thank you for tuning in. I am Chat Teaches Me C. That is what we are doing today at this very moment. Okay. So would it be simpler instead of this if I just do size of my linked list? Is that better? Do I not need to like typecast or something? I guess we can figure that out when we get there. Then we do need to typecast for sure. So we gotta do like parentheses. Oh no! I didn't mean to delete your message, Monterabyte. I'm so sorry. I'm so sorry to delete your yeah. I gotta be more careful where I'm clicking. I am a very clumsy moderator. Malik returns void in C void. So if I do it in 2 lines though, does that mean I don't have to typecast anymore? If I do it like this, that's okay, right? Definitely trial and error with the typecasting. Oh no, this wouldn't be okay either. Okay, I don't know. I'm just gonna do it in 1 line and typecast. I can do it in 1 line without typecast. I'm gonna leave the typecast out and just like see what happens. I'm just gonna see what happens. Okay, so we're doing this, and then down here we're doing this. Okay, this looks good. This looks good. And then we have our new node, and then we want to new node equals dot val equals val comma dot next equal to object, right? Is that, hopefully that's okay? It would be star new node like that? Are you sure? I feel like object isn't a node though. Oh yeah, we gotta do object arrow head. Object is a linked list, which just basically keeps track of a head node. C is so rusty for you, but what about Rust? Memory returned by malloc is uninitialized, so I need to assign each field manually or make a temp struct instance and assign a value behind the pointer to the temp value. Wait, is that not what I'm doing here? Is that not what I'm doing here? That's what I was trying to do there. Okay, good. Okay, good. Okay, good. That is what you're doing. No, I'm trying to reassign the new node. Uh-oh. Yeah, I also need to add, change the head too, but I'm just trying to get the syntax right here. I have to tell node arrow next, if I recall, or something like that. It's star new node, not new node. Really? To get the value of new node, I'd need to do new node equals node dot dot dot. Alright, not that I do believe you, but I kind of want to like see the error first. I'm gonna leave this like this. I'm gonna put like a comment. This syntax probably wrong. I'm gonna see what like the error though. I want to see the error first and then I'll fix it. So we are, let me add comments here. Allocating memory for the new node. This is setting values for the new node, and then we need to setting head to be the new node. So then we're going to object, is it object arrow head equals new node star? Question mark? Question mark? I'm gonna speed through this and get like the logic down first, and then we'll like press play and like see what all the syntax errors are. Just new node. Okay, that I can believe that. No question marks in C. True. Head is a pointer, new node is a pointer, so no magic symbols required. Okay. Alright, I'm only slightly confused. That's okay, that's okay. Alright, so adding at tail, I wonder if we can run this and see. Well, okay, let's just keep going. Let's keep going. We got this, everyone. And then we can talk about cats as a nice little treat. Okay, so adding at tail, what we gotta do is we basically we need like a while, right? Because we wanna, well, we can start by creating the new node. So node star new node equals malloc size of node, and then new node equals dot val is going to equal val, and then dot next is going to equal null because this is going at the end. And then so this is allocating memory for the new node. This is setting values for the new node. Your best friend O of N traversal for adding towards the tail. So yeah, a while. Yep. Okay, so and then we're gonna do like while something. Hopefully that is valid C syntax. We are going to create an int. If only we did a secret optimization. A little secret that will help us later. No, let's keep it pretty simple for now. No I have a feeling, like, if I can get through this in pure C with, like, 0 optimization, I am so happy. We are so good if I can figure out how to do that. Okay, so we're creating an integer. Is it just int? Int, yes. Int I. No, int, no, we're going to create a node current node. And that's going to be a pointer. Node current node, and that's going to start at object head. I know that none of my pointers are right, but we're gonna worry about the consequences of our actions later. And then, while current node next does not equal null. I thought we discussed having a tail pointer. We kind of did in, like, the abstract, but it's not something that we have implemented here. And like I said, I think as long as I can get, like, a very basic implementation in C, I think I'm gonna be real happy without any optimizations. By the way, pointers are nullable, so my linked list pointer object could be null, so technically I'd need to check for it. The quickest way to terminate on error is assert.h. Oh. Yes. 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 I'm gonna, okay, so I guess I'll just... Okay, I'm gonna worry about the edge cases later. I'm just gonna try and get, like, the basic happy path working. And then I'll get to the edge cases where I want to check for, like, error cases. Does that sound reasonable, chat? Is that okay with you guys? It's a serple, so it's easy to use. Okay, let's do that once we get kind of, like, the happy path working. I just want to, like, get it basically... like 90% of the way there, you know? LeetCode is not the place for proper error handling and program termination. Why do I keep pinning things? I really need to stop doing that. Unpin. Alright, this is fine. This is fine. I always code in LeetCode only for the happy path. I mean, they're probably going to test the error cases when I actually submit it. That was a good pin. That's true. Alright, so we're gonna go through, and while the next node is not null, then we're going to set current node equal to current node next. Arrow next. It's gonna crash anyway at the end. Okay, and then when we get to the end, when next is null, then we're going to set current node next equal to new node. And in theory, as long as I cutely decorate my edge cases later. Exactly. The memory leak is LeetCode's problem. Yeah, no, with the current code, I don't think it's even gonna run. It's not going to fly. Least of all, will crash and burn. So we're still getting there. We're still getting there. Who cares about memory leaks? We just need a solution. I appreciate that attitude. Okay, so we've got adding to the beginning, adding to the end, then we want to add at index, so it's going to be similar to adding at the end, so we're going to still do this the same way. We create our new node, and then at index. Okay, so they said that if you're inserting at an index, you want it to be inserted before it. So what I'm gonna do is, let's say int I for I equal to 0, I less than, index. Okay, I might be off by 1, but I'm just gonna say I less than index, I plus plus. That's how I did, yes. C is fun, it's like a mad crackhead scientist. It makes the forbidden magic happen, but at what cost? Okay, so we're gonna loop through until the index, and then I think because it's all 0 indexed, when we are at less than index, I think we're gonna be 1 before the index that we want to place it before. So I think that when we stop here, it's gonna be our before, and then our after is gonna be the one we're inserting it before. I can do for int I equals, wow, amazing. Advanced technology. I'll do that up here too then. Okay, and then, so we're gonna loop through, and then we're going to, again, create a current node, pointer, And then we're going to current node next, current node equal, yeah, current node equals current node next. And then by the time we're done with that, we're gonna be ready to insert. And so, current node, we're gonna do, next pointer is gonna be another node. Oh, we can set, new node next is going to equal new node.next is going to equal current node next. And then current node next is going to equal new node. I think that should do the trick. C has always had auto, just makes everything void. A void. A pointer to void. That sounds so useful. Originally, auto is the default storage specifier like static inline extern. If you don't care and want to be explicit about not caring, you say auto. Not the auto type deduction like in C++ though. Void is like TypeScript's any. Ah, so it's useless. It belongs in the garbo. We'll be back soon! Also, semicolons everywhere. True. True. Thank you so much. Kwang-sama, take care. I'll see you soon. いってらっしゃいませ、ご主人様. Okay, let me go ahead and add semicolons everywhere. Oh, hydrate! I'm gonna have to go and refill my water. So I will BRB real quick so that I can stay hydrated. Thank you so much for the reminder. I will be right back, Goshujin-sama. Take this opportunity to get some water yourself as well. Alrighty, Go Shujin sama, I am back with some water. I hope you all stretched your legs a little bit and got some water yourself so we can all stay hydrated together. Drink that water. Just like our cat has been drinking water. I can't wait to give you this update later. I can't get up to stretch, there's a cat. True, but maybe the cat has been stretching. Oh no, linked lists! I haven't seen those since uni! Zero Arc-sama, o kae ri nasai mase, go shujin sama, welcome to the computer lab! Yeah, and you know what else you probably haven't seen since uni is C. Cause that's what we're doing it in, because the chat demanded a blood sacrifice. And so here I am. Skipped a minor just to clutch a deadline on linked list with C++. It was worth it. Oh man. Like, you could have had like a minor in your degree, like in addition to your degree, but you skipped it to like do C. How does this work out? Please explain. Elaborate, Tsubasa's sama. That's true, I was not going to use the peak 2015 web development build system aesthetic. Well, I would have, it just didn't make a... What does SAS have to do with linked lists? Am I gonna implement linked lists in CSS? No, I don't know what you want from me. We can do that for another stream. That can be for another time. Extremely evil. I agree. I agree. Actually, that would be a fun, like, April Fool's Day stream. Is, standing up a new project and, like, the prank is like, wake up! It's, the year is, like, 2005. We gotta go to our web development job. Actually, that would be kind of fun if I, like, looked up, like, the history of maid cafes, right? Like, the very first maid cafe was, like, early 2000s, right? So, if I got for my avatar, I could get, like, an outfit that was, like, it was a Deji Kyara, cosplay cafe, I think was the, like, generally considered to be the very first maid cafe in Akiba. So I could make myself, like, a Deji Kyara, like, outfit for April Fools, and then we could do, like, we could do some programming as if we were in, like, that year. Back then when webmasters existed. That's called trauma bullying. Exactly, exactly. We can make websites with Flash! Oh my god, yes! Flash stream. Flash stream in my Deji Kara maid outfit. Flash mention. Dejiko programming in TypeScript, run for your lives. Exactly. Well, I don't know if you can tell, but my character is like low-key, like inspired by Dejiko. She's my inspiration for like the apron shape. Though I need like a bigger bow, if I really want to be like in fashion for Dejiko. But I do love a good green-haired maid. Don't get me started on Flash. Actually, please do. I can go on for hours about it. That's right, S-Vision-sama. Tokyo Character Show in August 1998 featured Pia Carrot Restaurant. Yeah, we gotta do a 1998 flavored programming stream. Actually, I feel like that'd be kind of fun. Like, I don't know how many of us are old enough to be traumatized by 1998, technologies. Atik Plumi-sama, okaeri nasai mase, go shujin-sama, welcome to the computer lab. Thank you so much for coming. I appreciate your glow stick emotes. Back in early 2010s, I kind of ended up working in a legacy project in Cold Fusion. What the hell was that language? I don't know. Please no. Please do not make me find out. I do not know, and I do not want to find out. Alright, where were we? We were, deleting at index. So to delete at index, we don't need to create a new node, but we do need to loop through to find the node at the index. We want to find the index before it and the index after, so I think we would stop at less than index, not less than or equal to index, hopefully. And then what we do is current node next equals current node next. That should do the trick, I believe. Yeah, you're sidetracking for no reason. You're sidetracking for fun. Oh, Deji Kara manga was also 98. What a good year for anime. What about Prev though? Well, my concept is that current node is essentially the node, because we want to delete the node at index. And if index is 0 indexed, then I less than index is going to give us, current node is going to be the node right before the node that we're trying to delete at index, I believe. I think. First time saying next, you'll like the hare and tortoise algorithm. Node next is this JavaScript. When you see so hard, you become TypeScript. Oops. I lost my place. Okay. Where were we? Yeah, I don't think we're gonna worry about freeing memory in this stream. I don't think we're gonna worry about that right now. We've got bigger concerns. Yeah, so the idea is that this should be the previous node at this point. So we're setting the next of the previous node to be the next. Hopefully that works. Free will never see the light of day. Like I said, no one here is free. If you're here by definition, you are not free. Okay, so then, my linked list, my linked list free. Uh-oh. What is that supposed to do? My linked list free. What the hell is that? Does it just delete it? I don't know what this is supposed to do. Object head equal null, I guess. I don't know what they want from me. I guess. We'll see, we'll see. If you delete the node at 1, node 0 is still pointing at 1. What I mean is that I'm pretty sure the idea is that, like, if we're deleting index 1, then I less than index, let me think this through. So, if index is 1, and I starts at 0, when you're at 0... Oh, we gotta do index minus 1. I was off by 1. There. This should do the trick, though, because then current node ends up being the previous node. And there's gonna be some edge cases that we need to figure out, but I'm just gonna run this first and, like, find out what the, yeah, okay, line 6, character 3, error unknown type node. Did you mean G node? No, I did not. Line 6, character 3. We didn't get very far, did we? How do we make a self-referential type def? Type def struct node, like that. I need to name the struct. Let me double check in here for structs. For loops, data types? No, those are like basic data types. W3 schools, you know what? They have good documentation and tutorials, I gotta say. Structures. Okay, what even is type def here? Type def keyword lets you create a new name for an existing type. Type def float temperature. Type def with struct. Lets you avoid writing struct every time. Okay, struct car. Type def struct car. Basically what you did is declare a nameless struct and then declare a type alias for the nameless struct. Type def struct node node? Yeah, I'm also confused. Struct. Is it like that? This seems weird. I don't know about this. The node pointer inside node also needs a struct. What? Struct node next. Oh. And then we don't need... Okay, hopefully that works. Let's see. Okay, we got farther this time. That's a good sign. Structs have their own namespaces and the normal namespace for variables and functions and a separate namespace for structs. To separate structs and non-structs, you say struct x. Yeah, okay, that makes a little sense. I got confused because they're using typedef and that made it like a little bit less explicit, I feel. But yeah, I think I kind of understand what's going on. Barely. Nishi codes! O kae ri nasai mase, go shujin sama! Welcome to the computer lab! What does Nishi code? What does Nishi code? Everybody on the internet wants to know. Allows you to do stuff like struct node equals node blah, where struct node is a struct and node is a function. Oh! That, I see. I see why. Oh, you do Flutter. Flutter is for mobile development, right? That's really cool. That's really cool. Currently learning. Good luck, Go Shujin-sama. I hope that you learn a lot about Flutter. Okay, while I am learning a lot about C. Ooh, Flutter. Tsubasa, have you also done some Flutter? In the meantime, let's see how far we got. Line 24, expected a semicolon. Did I forget some semicolons? You bet I did. All right, so we got semicolon, semicolon, semicolon. I don't need a semicolon like after the if statement, right? That seems like a lot. Semicolon, semicolon. Gonna be a lot of semicolon errors. Yes, it's true. That can't be the only missing semicolon. No, because oh no, that's not one. Okay, here's one. Here's one. Missing semicolon. Missing semicolon. Missing semicolon. Missing semicolon. Missing semicolon. Missing semicolon. The struct is still nameless on line 6-ish. So struct node still references the non-existing name. Really? But but the error isn't erroring anymore. I didn't get an error, so I assume it's fine. Okay, let's see. Maybe this is the error that you're talking about, though. Okay, line 32, assignment to node pointer from incompatible pointer type struct node pointer. On line 32, 32, current node equals current node next. And that's probably because of what you were saying, Raspered Valsama. Just get rid of the type def. I could, but I kind of want to keep it there because that was like the boilerplate. That was the boilerplate that LeetCode provided to me. So I kind of want to try to keep the boilerplate intact, you know? Well, I guess they made this a struct, but or a type def, but they didn't necessarily make this a type def. So do next after struct. Type def struct next. Add next after struct. Type def struct node should fix it. I might as well add node next to struct. Does that do something? I guess that did resolve it, but what the hell does this mean? I'm so confused. What about if we don't, cause, okay, so it can mess with things if we change the boilerplate, but node was not boilerplate. So we can remove type def from node safely. So then it becomes struct node. Like that? Struct node is naming the struct. Type def node is naming the type def. Do it in 2 steps. Struct node. Type def. Struct node. Node. I see. If I remove type def, then I need to write struct. Okay. I'm just gonna leave this like this. I kind of get it. I kind of understand it. I basically get it. Oh, Nishiko's is also learning Rust to rant about it. Do you not like it? Do you not enjoy Rust? I forget who I was talking to, but recently somebody kind of like badmouthed Rust. They were like, oh, it's kind of like a cult of personality like situation with Rust. And I was like, oh, that's interesting. I've only ever heard good things about Rust. So I guess everyone I know is in the cult of personality. Oh yeah, line 4 is missing. Type def. Okay. Everything is Rust nowadays. That's just an annoyed C dev. Well, if I'm annoyed trying and failing to write C, does that make me an annoyed C dev? That makes me a Rust dev! Rust people tend to say rewrite everything in Rust, so that makes non-Rust devs a bit defensive. That makes me a regular C dev. Alright, where's my next syntax error? Let's see. Line 43, expected expression before curly brace. Okay. Line 43. Expected an expression. I'm doing this wrong. Did I already do that kind of thing, though? Syntax is probably wrong. I mean, I could instead... Accurate comment? Yeah, that's funny. I could do new node arrow val equals val. New node arrow next equals object head. Do it one by one, maybe? Yeah, I think that would work. Let's see. Try with pointer new node. Oh, we got another one. Semis. Siki-sama, you're banned. You're not allowed to debug this. Okay, line 53, same issue, right? I'll just do these one by one. New node arrow val equals val semicolon. New node arrow next equal null semicolon. Is the cat's name Semi? How fun we get crazy error after the easy error. Okay, let's see. 68, expected comma or semicolon before new node. Okay, let's see, line 68. Oh, that's, let me just do the same thing. New node, arrow val equal val, new node, arrow next equal null. Okay, I'm back. Are you winning? Well, we are compiling more and more of the code, so I would consider that a win. Line 68, is that where we just came from? Oh, we also need a semicolon here. There we go. Okay. I can do star new node equals to typecast null.val equals. Oh, okay, okay. Okay, let me do that and see if I still get stuck on the same error as before. New star new node equal typecast to node dot val equals val dot next equal object head semicolon. Does that seem to work? Oh, it's a struct literal. It's not a typecast. Syntax. Okay, well that does work, but honestly, I don't really understand the syntax, and I'm doing so many other things. I'm just gonna do it the really dumb way right now, because I understand what's happening here. I'm just gonna keep it real simple. I missed another semicolon. Yes, I'm sure I did. On line 72, probably line 71 then. Yes. I sure did. So many missing semicolons. I'm used to writing in TypeScript and then like prettier parsing all of my semicolons out, so. Ah, Kotoe-sama, you finally reassembled your keyboard? You're typing on it right now! Yay! All your switches are hot swap and hot swap mod works. Yay! TypeScript does support semicolons. They're just optional for the most part. And so I usually never use them, but some people usually always use them. Just depends on what formatter you're using, usually. Using semicolons in TypeScript is normal. Yeah, it is. Alright, let's see. Current node undeclared on line 86. Current node undeclared. Okay, on line 86. Do I need star current node? Is that why? Oh, it's a typo. Oh, yep. It certainly is a typo. Thank you, Go Shujin-sama. You all get extra credit. Okay, Raspberry Val is explaining it. Basically, node ... creates a temporary instance of node. Star new node says, give me an assignable reference to the value behind the new node pointer. So star new node equals, oh, I get it. I understand. That makes sense. that makes sense. Once I get through all the errors, maybe I'll go through and replace it now that I understand it. Line 86, runtime error, member access within null pointer of type struct node. Member access within null pointer. That means that I tried to get something on null, right? We're on runtime errors now. Yes, good sign. Good sign. Okay, so probably we're trying to get like value or something off of null. I feel like that's probably what it means. So if we go to line 86, it's probably here. Hydrate. Thank you so much, Wonderbreads. Thank you for the hydrate. Stay hydrated, everyone. Drink lots of water. Okay. So it's probably either here or here. Current node. So, oh, we gotta do a check here. So, if current node, next is null, then we want to return -1. Is that right? Kind of like what we did. We did that somewhere before, right? Yeah, we did that here, so we want to do the same thing, I think. Oh, the return type is void? Okay, so then we probably just want to return. We'll just return nothing then. I think. Delete at index. That makes sense to me. I still might be off by 1, but this should be okay. Hopefully. Runtime error. Member access within null pointer of type struct node. Line 89. Another one. Okay, so... Oh, right, because this is not guaranteed to exist. Oh, there's still the bug present. What if current node is null? Ah, okay, so then we gotta check, we gotta guard here. If current node is null, then return. And I think also the other problem that we're having here is that current node next might have null next. So in C, like I know how I would guard against nulls here in JavaScript, but because this is C, I guess we do current node, and then we can do next node, node star new next node equal current node next, and then if new next node is null, then we return. Otherwise, new next node Okay, this is like a little bit confusing to read, but I think that this will work because we're guarding against the situation where the first next is null. I don't love how I've like named things here, but let's just see if it fixes the error. That was on line 89. Now we have an error on line 81. Did we go forward or backward? I feel like we fixed the error, so let's see. Line 81, error, current node undeclared. Line 81. Oh, yeah, current node is null. We actually want to, object head. Or we can just put this underneath. Still seeing. We're still trying. Oh yeah, and this is in the wrong place too. Good catch, good catch. Okay, let's see how that goes. Okay, line 92, expected expression before... Oh yeah, I got the semicolon is in the wrong place again. On line 92. We're gonna get there. We're gonna get there, Chad. Okay. No, 2. Did we do it? Okay, well, it passes the basic test. I actually don't need braces if the statement only has one statement in the body. Oh yeah, it's true of JavaScript too. For some reason, I usually leave them in just I don't know, for readability. I don't know why. Force of habit. All right, I'm gonna submit it, and I'm sure that there are some edge cases that we miss here. So let's address those. And that has caused a bunch of bugs. Yeah, I just feel more secure. I feel more secure. Same line curly braces is so new to me. I always break after curly brace, even if it's just a one-liner. That's because you're a good person, Tsubasas. That's because you're a better person than me. Alright, wrong answer. Let's see. Oh, it's very hard for me to read what exactly is wrong here. Like, I see the output and the expected are different. I see where it's different, but like, what was it that failed here? I see. So it's like doing all these things. Okay. Let's not litigate brace position. I mean, basically at the end of the day, I do whatever my current formatter tells me to. So, you know, when I am writing it by hand, I always include the curly braces, but then I just run like format, and then I do whatever the format tells me to. The 0 seconds became 5 seconds somehow. Yeah, what is it? Like, it's completely non-deterministic how long, these functions take. It's not a good, metric to see how long that individual, run took. But okay, so this is like doing all of the things. So let me switch over to my whiteboard, so that we can see what it is doing and what it is supposed to be doing, yeah? All right, let me pull up, my whiteboard on my tablet. Oh my god, there's a Wikipedia page debate. Of course there is. Of course there is. Pulling out the whiteboard. Okay. Start this up on my tablet. And I think I'm also going to need to... There we go. This should work. Yes. Okay, great. Okay, so let's look at the okay, so the input was okay, so in that is like really okay. So in put, y'all can see that, right? Okay, good. Okay, so the input was my linked list, add at head. I'm trying to like understand what I'm reading here in the input. My linked list, add at head, add at head, add at tail. Okay, I think I understand how to read this. I still want to redo my whiteboard overlay so that it's being done in MS Paint. But we are gonna work on it. We're gonna work on it. Okay, so input, my linked list, add at head. We do another add at head, we add at tail. Add at index. Get. Add at tail. Add at index, add at tail. Add at head. And then add at tail. Okay, and then I think if I'm reading this test case correctly, because there's like a big long string at the end, so is it gonna be like, are these like the inputs? 0, 3, 5. Yeah, these are the inputs. 2, 3. 1, 1, 2, 2, 3, 5, 6, 3. Okay, so these are the instructions that it went through. And the output is supposed to be Null, 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 null. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is what the outputs are supposed to be. Got it. Okay, so the output is supposed to be null, null, all the way until probably the gets, right? The gets are supposed to be 5. We expected it to be 0 and 0, and we got 5 and 5. And then the rest of these are supposed to be null. Are you following me? Are you following me? I think I understand how to read the test case. So if we step through, we create a linked list. We insert at head 0. So this is head. Let's group that so we can move it around. Group. Okay. So this is the head. The head is at 0 currently. We add at head 3. So the new head is now 3. Followed by a 0. Add at tail 5. Add at index 2, 3. So it's supposed to, so this is index 0, index 1, index 2. I'm confused why a maid isn't writing with ketchup. Yeah, it should be red. I have actually been thinking that I want to do like a points redeem for omurice decoration, but I haven't gotten that all set up yet. But we'll get there. We'll get there. What was I? Oh yeah, there's the indexes, and then I want to double check. Add at index the first. So it's index and then val. So the index is 2. The value is 3. And it goes before the index. So really what we are looking at here is we want to move... Whoops. Can we like move this? Wow, that got all messed up. Okay, I'm gonna delete stuff and rewrite stuff. So our new, we're gonna insert something in here. So the 5 goes here. And in here is the new value, which is 3. I really need to like turn off my hand. Okay, and then we want to get what's in position 1. Here's the catch-up. We want to get what's in position 1. Okay, so something went wrong, because it's supposed to be 0, but in reality it's actually 5. How did we mess up that badly? How did we mess up that badly? Okay, let me go through and check what is my code is actually doing at each of these points. Okay. So my linked list I think is fine. Add at head. Add at head. So let me move this over, and then we can compare what's actually happening. So we have our linked list, add at head 0. So what add at head 0 does is it creates a new node, and then it sets the value to be the value, in this case 0. And it sets head. Next, it assigns next to the current next, which is just null. I guess I can be explicit about that. And then it sets the head of the list to be that node. Okay, doing good so far. Doing good so far. Then we do that again. Add at head 3. So we create a new 3 node. We set the next after that 3 to be the current head, right? Yes. And then we move the head to be the top of the list. Okay, we are still doing pretty good. I have a feeling that the problem is going to be add at index, but we will see. I could try illustrating the exact data struct of the node as 2 boxes, val next, if it helps. Yeah, I think that's essentially what I am currently doing. I guess it's just like the box is just one box with an arrow, but you could like view it like that, like 2 boxes, right? I think that's what I am. I think that's what I am currently doing. I believe. Okay, so we did these 2. These seem good. Add at tail. Glitch, I know. We're gonna figure it out though. We're gonna get to the bottom of it. I believe in our whiteboarding abilities. Okay, so the next thing is add at tail. So let's see what my code currently does for add at tail. Let's step through it. Okay, so add at tail, we are creating a new node. The value is set to val, so in this case 5. The next is set to null. And then, while current node, okay, this there might be an off by 1 error, so let's see. While current node, so current node is, let me do this. Current node. Let's grab that. Okay, so while current node, so current node is the head, starts with the object head, and then while next does not equal null. So as long as next does not equal null, current node equals current node.next. So at this step, we have a next, so we iterate. At this step, next is null, so we stop. So current node is here. And then we set current node next to be the new node. Okay, this is looking good so far. This is looking good so far. That definitely added 5 at the tail. 305, and then add at index. I bet that this is where we're getting the error, but let's see. A classic, but there are only 2 hard problems in computer science: cache invalidation, naming things, and off by 1 errors. Extremely true. I say that all the time because even though it is a little cliche, it is always true. And time zones. Boy howdy, and time zones. Oh, you haven't seen the Midori spinner yet? Well, I haven't been like... I mean, I'm kind of working through stuff here, but I'm not like totally confused. I usually reserve the spinner for when I'm just like dead silence confused. I haven't actually reached that point yet. Surprisingly. Shockingly. It's because C is easy. You could say that C is in my blood. Ooh, hydrate. Thank you so much, Wonderbreads. Thank you so much for the hydrate. Okay. Okay, now we're adding at index. I bet this is where we get some kind of off by one error, but let's see. Add at index. Okay, so what are we doing? We are creating a new node. We're setting the value to be the value, which in this case is 3. And we're setting the next node to be null. Oh. We set it later. Okay, that's fine. That's fine. It's kind of unnecessary, but that's fine. Okay, and then, so we've initialized that, and then we set current node to be the object head. There's the current node. And then for I equals 0, I less than index, I plus plus. So I starts at 0. And every time we increment, we do current node equals next. So I is currently, I'm just gonna have like an I counter over here. So I is 0. We set current node equal to current node next. So this moves down. And then I is 1. 1 is less than 2. I is less than 2. So we do it again. We move this down. I is now 2. So we stop here. 0, 1, 2. Yeah, this isn't off by 1 because we actually wanted to stop up here, I believe, because we want it to be, this is index 2, and we want to insert it before index 2. So we actually want this to be index I less than index minus 1. If we do that, I less than index minus 1, index is 2, index minus 1 is 1. Am I babbling? Am I babbling, Go Shujin-sama? Let me know if I'm babbling, because this is 0, 1, 2. Current node starts at 0. I is 0, current node starts at 0. We move it, we move it down, and we increment I to be 1. 1 is no longer less than 1, so we stop. 1 is less than 2. Very good. Exactly. Yeah, you gotta be really good at math to be a good programmer. That is definitely true. Okay, so we stop here. This is now current node, according to our updated code. So now, new node next is going to be current node next. So this is the new node. This is the new node. This is the new node. And we're setting new node.next is now not going to be null. New node.next is going to be current node.next. So this is like that. Yes. And then current node next is going to be new node. So we are erasing that. Oops. and doing that. Okay, that is now correct. 3035, 3035, okay. So now that should be correct. And then we want to get number 1. I bet... Because I think there were 2 off by 1 errors. I think we were off by 1 there, and I think in our get we were also off by 1. I had a D on masses. Oh, good morning, Meta Furuya. Okaeri nasai mase, go shujin sama. Welcome to the computer lab. Or should I say, ohayo gozaimasu. Go shujin sama. Welcome to the computer lab. 2 off by 1s, and they didn't cancel out. I know. So sad. So sad. Because I think at the end of the day, we wanted... Like, this would have been correct. We ended up off by 2 somehow. So I think there was also an off by 1 error in our get. So let's see how that works out. Okay, so, delete at head, get. Okay, so here's our get. Let me rewrite this to be a little bit cleaner. So we now have 3 is our head. 3, 0, 3, 5, null. Erase these. Oops. Okay. All right, let's see about getting at the 1 index. Indeed, it should be 0, not 5. Okay, so, node, current node is object head, once again. That's the current node. And then, let's get our I counter again. Our I starts at 0, and then we want it to be less than index, which in this case is 1. Less than index 1. Okay, so, our indexes are 0, 1, 2, 3. So, current... Okay, so for I equals 0, I less than index I plus plus. If current node dot next is equal to null, it's not. So we don't do that. Instead, current node equals current node next. So we move this on down, and we increment I. We stop there because I is now no longer less than 1. I is equal to 1, it's not less than 1, so we stop here. Oh. And then we return current node value. Okay, this should actually work. I don't know how we ended up 2 off before. But, let's see if this now just works. That would be nice. Let me go back over to our window scene. Run it again and see. Exactly. Okay. 5500. Let's see if we get a new wrong answer now. Oh, I gotta submit. Okay, we got a different wrong answer now. Output is 33, expected is 00. I think 035 2311 223 okay, we are off by 1 somehow. I think my intuition is that it actually needs to be get, oh, less than or equal to, less than or equal to. Yes, we were off by 1. It just needs to be less than index, and then we will be good. I promise. Yes, we got farther now, I think. Unless we broke something earlier, I don't know. Okay, new problem. We create a linked list, we add 1 at the head, we delete at index 0. Now we have an empty linked list, right? Add at tail 2, so now we should only have 2. Oh my, what happened here? What happened here? This is why I wanted to TDD it. But okay. Let's get out the whiteboard again. Let's get out the whiteboard again. All right, let's delete all that. Okay, so add at head 1, delete at index 0, add at tail, add at tail 2, get at index 0. The whiteboard is the TDD. Yeah, I guess so. I guess so. All right. So if we're doing this on the whiteboard, we start by adding at head 1. That becomes null. And then we delete at index 0. So it just becomes null again. And then we add a tail. I bet there's some, I don't know. We'll figure it out. We'll add a tail 2. Since there's nothing, that's just gonna do this. Oh, I know. It's because I didn't handle any of these edge cases. That's definitely what's going on here. And then get at 0 should be 2. Okay, you know what? Actually, I am going to, let's go back, because I don't need to step through this. I'm pretty sure it's just because I didn't handle any of our edge cases. When the path is no longer happy. Exactly. I didn't handle that. So let's look at, okay, my linked list create, there's no real edge cases there. Get, that's fine, because the only real edge case is if object is null, I think. Add at head. Okay, so add at head, I think this does the same thing, whether or not the list is currently empty. So I think this is okay. But adding at tail, we definitely need to handle an edge case, because we wanna check if object is null. Yeah, if object is null, then we are going to actually return my linked list add at head object and val. I think that's what we want to do. If we don't currently have a head, then we're essentially just adding at head. I think that is the trick. And I guess, My linked list isn't the head though, it's the container. Yes, we want to check if the head is null. Yes. Okay. It must never be null. I mean, technically my linked list could be null, right? Because my linked list, or object could be null because object is a pointer, and the pointer can be null, right? Right. But I don't think that's what's going on in this example. I think if we do this, if we check that the head is not assert object, yeah. I'm gonna worry about that later. That is not the problem that we're having right now. Yeah. Okay, so, but this is a valid state where the head is null, and if it's null, then we are going to instead add at head rather than adding at tail, because it's the same thing at that point. And also, in this case, I guess we can check if object at head is null in this case, then, do we do anything different in this case? We create a new node. Next is object. No, we don't have to do anything special. This is all we have to do, I think. Add at tail. Add at index. We also want to check. Well, I'll get there. I'll get there when I get there. Let's see if I run it now, if we get the same problem. We do still get the same problem. Why are we getting the same problem? Alright, maybe we do need to whiteboard it after all. Do I even need add at tail slash head? Because we're essentially like adding at index. Well, add at tail is useful because add at index, to add at index to the tail, we would need to loop through and find out how long the list is, because we don't know that up front. So I think we do need add at tail. Add at head, we could arguably just call add at index 0. Arguably. I'm gonna whiteboard through this again. I'm gonna whiteboard through it. Let's see what we got. Let's see what is going on here. Alright, so we have these. This is what is supposed to happen. This is very much not what is currently happening. So let's see what is currently happening. So let's step through it again. So add at head. So our list is currently null. The head is null. That's the head. And then add at head 1. So add at head. Gotta go for now. It's late, but good coding sesh. Thank you so much, Zero Arc-sama. Please take good care. Have a good night's sleep. And itterashaimase, go主人様. Lurk time. I'm off to do some astrophotography. Oh, very cool. The stream will be good to put on while I sit outside for hours waiting for my camera to take photos. Good luck with the problem says good luck with your astrophotography. If you post your photography somewhere, you should definitely drop it in the chat and or the Discord. I would love to see your sky pictures later. That sounds very cool. Alright, so we're at null. We're adding one at head. So add at head, we create a new node. The node's value is the val, which is 1. We set next to be the current head. So we move this up and we point to the current head, and then we move the head pointer up. Okay, that looks good. Okay, I'm sure that there's an off by 1 error with our delete now. I'm still, I'm narrowing in on it. Are you still winning, guys? Well, we're making progress. We're making slow but steady progress. We are doing something. Oh, there's a meteor shower around this time. That's really cool. That's really cool. If you've ever played, Animal Crossing, New Horizons, I don't know if it's a feature in other Animal Crossings as well, but in Animal Crossing's New Horizons, meteor showers are always very exciting to go and try and make wishes and get stars the next day, get like gems, so definitely catch as many gems as you can while those meteors are passing by. Okay, so delete. I have a feeling that this is where the bug is. Now, so let's look at delete at index. I have less than index -1. It's probably because it needs to be less than index, but let's see. So, delete at index. So current node is the head. So we got current node here. And then I is that, while I is less than, index we said 0. So 0 minus 1, yeah, this is definitely wrong, because this doesn't do anything. So current node stays there, and then is that wrong? Maybe. Current node stays there. And then, new next node is going to be current node. Oh, yeah, okay. This is totally wrong. Because what we're saying is the new next node is going to be, let's use blue for this, I guess. New next node is going to be current node next, so this is new next, and then we said do nothing if this is null, so it's saying do nothing. We do not want to do that at all. Let's think through what we actually want to do. In order to delete this node, we want to, like, let's do it in the abstract case. So we have like 1 ... 2 3 4 null. Alright, let's reason through this, Go Shujin-sama. So let's say that we want to delete this one. This one is, you know what, let's just 1 2 3, and then the indexes are 0 1 2. So let's say we want to delete at the 1 index. We want to, our goal is to move the pointer here. So current node starts at 0, and we want to stop whenever I is stop when I is equal to index. Stop before I equals index. So that's gonna look like I less than index. Yes. Not index minus 1, it's gonna be I minus index. Or I less than index. That's the first change we're gonna make. And then the second change we're gonna make is that once we get there, we want to set the current node next is going to equal current node next and instead of doing nothing, if this is undefined, then instead of doing nothing, we set it to be undefined. I see where the problem is. Okay, so we want to, okay, so what we want to do is we want to keep the list size in my linked list would make things easier. Yeah, it would. There are a lot of optimizations we could do, but like I said, I want to keep, to a pretty vanilla linked list implementation here, just because I think it's in the spirit of the question. Because once we start adding like list size and all these things, it kind of stops being like a pure linked list, right? At that point, I think so. But okay, so we want to get, basically our plan is get the node before index, and then set node next to be node next or null. So if there's no next, then we just set it to null. We don't do nothing like I'm currently doing. Hopefully that makes sense. So I'm gonna go ahead and transition back. Yeah, Sigval has used them in practice, which is pretty interesting. Okay, so let's go back to our delete. So, current node, if current node is null, then return, for I less than index, not less than index minus 1. And then, if current node next equal to null, let's say, node new next. Oh, wait. Yes, I'm pretty sure that this is still, well, we still want to do that, but then down here, new next node is going to be current node next if new next node equals to null. Instead of return, what we're gonna say is new next node not equal to null, then new next node is is equal to new next node next. So what we're doing is we're getting the next node, new next node, current node, next. Okay, I'm pulling out the spinner. It's officially spinner time. I gotta think this through. I thought I understood it, and now that I'm reasoning through it, I feel like I did something wrong. So, in theory, current node should be the one before the one we're deleting. So current node next should never be null. Current node next needs to be defined because that's the thing we're deleting. So what we want to know is if new next null, new next node should never be null in this case, because if it was, then we're deleting something that doesn't exist. We would get stuck here, I believe. So what we actually want to do is, okay, new next node equals the node we are deleting. And then current node next equals new next node next. I think I added that, like, if thing there to guard against a null pointer exception, but I think the null pointer exception was because it went off by one error here. We have three possible cases. Index is outside the bounds, index is at head, index is at tail, index is inside the bounds happy path. We do, but I feel like this is going to work for all of those. I'm just going to press play and see what happens. Member access with a null pointer exception. Okay, well this is good because this is actually the same test that was failing before. Line 93. Current node next. Current node next. Current node. New next node. Current node is null, or current node next is null. Current node next is null. New next node, current node, new next node. Oh my god, why is this so hard? Okay, let me make sure. So this says character 36 on line 93. So it makes it look like this is, right? 36. Let's see. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Yes. Okay, so new next node is null, and we're calling next on it. New next null after we set new next node to current node next. This should be the thing that we're deleting, so this shouldn't be null. Current node, which is the node before the one that is being deleted. Oh! I get it. I get it. I see what's happening here. Because in the normal circumstance, when you're deleting from the middle, it's gonna do a thing. But when we're deleting from the top, okay, it's when we're deleting, because, okay, so let me go back to the, let me transition back to our thing. Hydrate, hydrate, yes, hydrate. Hydrate for the knowledge, hydrate for the knowledge. Thank you so much, Wonderbread-sama, for the hydrate. Okay, so here's what is happening. Here is what is going on. I swear if I was doing this in JavaScript and I had done it with tests, I would have figured this out sooner, but okay. So, here's what's happening. So, okay, so here's what we said. We said get the node before the index. But here's the thing. If we are deleting the first thing, like in this case, this is what it looks like, right? And we're trying to delete this. So current node, in this edge case, current node is not the one before. Current node is actually the thing that we're deleting in this case because there was nothing that came before it. Current node is just the head. That's what's going on here. And so, we do need a special edge case for if the current node is the head. So we need a special, and that's not too bad, because finding out if it's the head is just saying, are we deleting at position 0? We just need to handle it differently if we're deleting at position 0. Got it. Okay, that's not so bad. We don't need to do so this should still be right. I think I did fix, like, future bugs by doing this. If current node equals object.head, we can also just say if index is 0. I feel like that's more straightforward. If index is 0. If index is 0, then what we want to do in order to delete the current node is all we do is we do object head equal to object head next. That's what we do. And even if it's the only element, if head next is null, that's fine because we're just setting head to null. And that's what we want to do. That should fix it. That should fix it. As long as I put a semicolon, that should fix it. Semi! Wait. Member access within null. Okay. We moved past it. We moved past it. This is a new error. Good. Oh my god, how long is this gonna take? Alright, back to the whiteboard. Back to the whiteboard it is. This is a problem on line 97, which is still deleting. Okay. Member access within null pointer, character 36, line 97. New, next node. Can you imagine how easy this would have been in TypeScript with PNPM and vtest? I know. I know. What if the head is null? Where does the head next live? Oh, that's a good point. Current node next. Is that, like, also the problem here? Well, okay, so let's solve it here. If, let's see, object head is null, then object head is null. I guess if object head is null, then we do nothing. In that case. If object head is null, then we do nothing in every case. Right? If object head is null, then deleting doesn't do anything. Return semicolon, yes. And then, yes, if index equals 0, we're doing that, and then we have to return. Yes. Yes, yes, yes. I'm pretty sure that we can guard against the object head being null because it doesn't matter what index we add. If the object is completely empty, then we're never doing anything in that case. Okay, let's see if that moves the needle at all. Not super confident that it did. Oh, yeah, this is a new thing. I think this is a different, this looks different. Line 102. Oh wait, where's the memory leak? Still not our problem. Okay, so it's saying that in this case, oh yeah, not our problem. Not our problem. Garbage collection isn't a thing in C. Yeah. Yeah, but it's also not our thing. That's for the garbage man. That's not for us. That's not for us to worry about. Okay, so the problem that we are having though is that member access within null pointer of type struct node on line 102 character 36. So it's saying that line 102. So it's saying that this new next node is null. And we were saying that in theory, this should be the thing that we're deleting. You can garbage collect stuff if you want. Nah, I like my garbage. What if we need it someday? Still hitting the case where the item being deleted is just after the end of the list. Okay, let's think through this edge case. Okay, so we figured that out. What if what we're trying to delete is at the end? So if we've got 1, 2, null, and we want to delete this one. Okay, well, get the node before the index, so that is this guy. In theory. Set node next to be node next next. Current node. Oh, deleting the non-existent valid. Oh, okay. I've heard a wild story about an intern looking at the self-guiding rocket code. He discovered a memory leak in the rocket's code and went to the team lead. Team lead said, "We know there's a memory leak, but the rocket will detonate way before the memory runs out. We just give it enough RAM." I mean, that's basically how people program these days, right? That team lead was ahead of his time. What if the memory leak causes it to explode? Then it's really a bug and a feature. So you're saying that it's, like, if this is our thing and we have things at 0 and 1, and we try and delete something at, like, 2, what happens in that case? In that case, because I was trying to guard against that, but let's see if I did not guard against that correctly. Okay, so first check, is head null? No, head is not null. Is index 0? No, index is not 0. Okay, so then current node starts at the head. Is current node null? Oh, we no longer need to check that because we're checking if current node equals null way up there. That's fine. Okay, so current node is the head, and then for I equals 0, I less than index, so I equals, and we want it to be less than index, which is 2. Okay, so I is 0, I is less than 2. So current node next is not null. So we move this up. Now I is 1. I is less than 2. We check, is current node next null? It is, so we do nothing. I think we already guard against that case. Because if we try and do 2, I is less than the index, but we don't have anything to next to, so we're already returning early in that case. So I don't think that's the edge case that we're working on here. Yeah, I don't think that the JavaScript versus C, I think the thing that would have made a big difference is if I had actually, like, done TDD and, like, written tests. I think that would have made this a lot easier. Which I kind of abandoned because I don't know C very well and I didn't know how to write C tests. I'm looping until it's less than index. Strictly less than index. So it should catch this edge case that you're talking about. Okay, I'm gonna actually look through what this test case is doing. So, oh, this is a really long test case too. Oh, gross. Ugh. I don't want to go through all that. I would rather just find the edge case. Okay, I wanna see what happens when we're deleting something from the end of the list. What happens when we're deleting something from the end of the list? That's the current node. I less than 1. Strictly less than 1. Okay, so when we're at 0, oh, it does need to be -1, I think, because in this case, oh, sorry, let me, oh, am I? Yeah, I am sharing. Okay, so, okay, so in this case, if the goal is to delete the thing at index 1, I starts at 0, I is less than 1. Let me actually look at my code. Object head is not null, so we skip that. Index is not 0, so we skip that. I starts at 0. Current node starts at the top. Current node.next is not null, so we don't return. And then we move current node down, which is wrong. Because we want to stop before it. But we have now incremented, and then we stop, so it does actually have to be strictly less than -1. Okay, let me put that back. I thought that I was fixing a bug by doing that, but no, it should have been index -1 the whole time. Let's see if that fixes it. I can't believe there are 31 people watching me struggle through, a C implementation of linked lists. I love it. I love it. This kind of looks like the same problem. Yeah, you are waiting to hear about cute cat life. Oops. Seki-sama has swindled you out of, we could have been talking about cats for hours by now. Okay. We're gonna figure this out though. Okay, so still null pointer exception on line 101 here. Holding out for the cat even though it's past midnight. Okay, I'm gonna do my best. Okay, let's go back to the whiteboard. I think I fixed one bug. which is that the current node now does stop before the thing we're trying to delete. Okay, so let's look at what happens next. So our current node is the one before. New next node. New next node is going to be current node.next. So this is new next node. That's the new next node. And then current node.next. The new current node.next is going to look at new current node.next, which is null. Okay, so that shouldn't be a null pointer exception. In that case, so what is going on? Won't current node advance to index 1? So, let's start over. This is our list. This is our list. We want to delete the last thing. My current implementation. In the example, we're trying to delete index 1. Because I already verified that trying to delete at index 2 is going to... already it gets caught in my current... in the current example. Oh, yeah, okay, let me check now. Okay, fair point. Let's double check. Okay, so let's say that we're trying to delete at index 2. Oh, thank you so much for the follow, Kwang-sama. おかえりなさいませ、ご主人様. Welcome to the club. Bedge. You'll see cat pictures in the Discord if you join later. Okay, so okay, so let's say let's check this again. So object head is not null, so we pass that check. The index we're deleting at is not 0, so we also pass that check. Then I equals 0, while I is less than index minus 1. In this case, index is 2, so that is gonna be 1. So while I is less than 1. Okay. We do the current node at the head. Okay, so 0 is less than 1, so we do the first loop. Current node.next is not null, so we don't return. And then we move current node up. And we increment. Oh, and now we don't get caught. Because now 1 less than 1. Okay. So we just add a check. If current node next is null, then we do nothing. Because there's nothing to delete. Let's see. Let's run it. Please solve the bug. Please solve the bug. $94, $78, $78, $94. Okay, well, it solved the bug, but at what cost? The great Charles the Ninth sama, o kaeri nasai mase, go shujin sama. Welcome to the computer lab. That definitely sounds like the kind of name that would live in a mansion with waitstaff. So I think you'll be right at home here. Tsubasa has to head early to touch grass with offline friends. Ooh, have fun! I can do this! I know! Wacky pointery fun stream today. Thank you so much, thank you. Albagami grimacing, I know. But, okay, the good news is that a lot of this looks right up to a point. I am new vibe coder. Are you vibe coder too? What agent is the one I use? Agent Grog. You are going straight to detention, Goshujin-sama. No vibe coding allowed in this chat. Don't make me tap the sign. Exactly. Okay, I am looking at the time. It is 10:30. I do know that I can do this, but I also would like to do this fast enough to get to the cat stories. So, Wonderbread-sama, I believe you were the one who redeemed the banning the Sidkey construct. Have we committed to the bit long enough? Can Sidkey come in and start helping us debug this? For the sake of cats. You have had the entire chat. How is this not solved yet? I don't even think this is C's fault anymore. I think this is just because I didn't write any test cases, and so all of my edge cases are completely untested. And now this is what we're dealing with. Okay, let me go through this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so let's see what's going on the 9th statement. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a get. We're gonna get through it, though. We're gonna get through it. Let's go back to the whiteboard. Okay, so the test example, what are we doing? We are adding something at the head. Okay, let's see. Okay, so we added head, added tail, added head, delete at index, add at index, add at head, add at tail, and then get. Okay, and the values are scrolling down. Ugh. Okay, the values are 63, 10, 78, 2, 0, 94, 78, 0, and 2. Okay, so Grok can do that if it wants. We don't really care what Grok wants to do in this chat. Not for this use case. You know, I did say vibe coders get detention, so I think the great Charles gets a timeout. The great Charles IX gets a timeout for all of the Grok talk. I was not joking around when I said that vibe coders get detention. I will use my detention button liberally. Okay. So we're on the whiteboard. We're gonna walk through the steps here. So we add 63 at the head, and then we add 10 at the tail, and then we add 78 at the head. Oops. And then we delete at index 2. So 0, 1, 2. So we delete that. We add at index 0, 94. So that's basically just adding it at the head. Clown World. This is a funny song. Okay, and then we add at head 78. Again. And then add at tail 0. And then we get 2. So 0, 1, 2. So it should be 78. Is that what we have in the expected? Yes. And instead we have 94. Alright, where did I probably go wrong? I feel like I'm pretty confident that add at head and add at tail is fine at this point. Oh, that problem was not quite... Oh, Siki's probably, testing it out. Thank you, Siki-sama! Band method grok, exactly. It does look like the get call is incorrect, because if I compare my output to the expected output, my output says 94 and then the expected output says 78. So it looks like somehow my things are getting shifted around. So I kind of want to double check, because I think head and tail is probably fine. So if we kind of like recreate this again, I kind of want to like step through and find where we're getting into some possible edge cases. So add at head, assuming that head and tail works fine, 63 adding at tail 10. Adding at head 78. Deleting an index 2. That feels like something that could potentially be an edge case, so I'm gonna step through and see what. Alright, I'm fully paying attention. Let's go through it. Yeah, okay, so I'm gonna step through my code, for delete at index, and, because I am on, ooh, hydrate, good reminder. Because I'm on the whiteboard, I'm gonna go ahead and copy over my code, into the chat. I'm sorry if this is, like, fully unreadable, but this is what delete at index looks like. Oh, that is not readable at all, and that got cut off. Okay. Wait, I think I can put it in, I think I can put it on the whiteboard. Hang on. Let me do that. Copy, and then go over here. There we go. There's my code. There's my code for deleting. So let's step through it. Let's step through it one by one. And see what we get. I'm gonna delete my message because that was not useful. Okay, so let's step through it and see what it does. So the head is not null, so we skip that check. Index is 2, so it's not 0, so we skip that check. Then we get current node. That's the current node. For I less than index minus 1. So index minus 1, the index is 2. So I equal less than 2 minus 1, which is 1. Why is, there we go. Okay, so first iteration through, 0 is indeed less than 1. Current node dot next is not null, so we loop this up here. I is now 1. 1 is not strictly less than 1. And so, we stop there. If current node dot next is null, it's not null. So we do not return early. Now we say new next node. I'll use this. New next node is current node dot next. New next. And then current node dot next is the next after that, which is null. So current node dot next is new next next. Okay, so that seems to do what we wanted to do. So job candidate, you claim to know C. Tell me what this perfectly valid C function without indentation does. Nightmare interview! Nightmare interview! Current node, new next. Okay, so that seems to be okay. that seems to be okay. So then we're left here. Add at index 0. We added the thing where adding at index 0 just adds at head, right? Add at index. Oh, we didn't. Okay, let's do that then. If index equals 0, return my linked list add at head object val. Let's see if that helps at all. It did! Oh my god, I'm so happy. No, we went back to where we were before. This is an earlier. That actually just broke something. Interesting. Add at index 0. My linked list add at head object val. Interesting. Oh, sorry guys, I forgot to switch over from whiteboard. Yeah, so what I did was I went here and I added index. I added a check that said if index is 0. Oh, index equals 0. That's probably why. If index equals 0. Okay, let's try this again. Basically, if we're adding to index 0, then we can just call add at head. It's like a special case, just to... Oh my god! We did it, chat! We did it! Oh my god! We did it! Wow! Oh my god, I'm so excited. Let's go! Hell yeah! Oh my god, we did it! We did it in C! X hours later, it was trivial. Thank you so much for the anonymous subs. Oh my gosh, thank you so much for the gift subs. Thank you so much for the stretch. Oh my god, we did it. We did it. I am the smartest person in the world. Oh my god. Okay. Wow. Nothing better than a good backcrack after shrimping over a problem. So true, so true. Okay, this deserves a stand-up. This deserves a stand-up. Okay, we're standing up, everyone. If you can, stand up with me. We're gonna do a big stretch. So I really gotta get body tracking on here, or at least, like, you know, animate my VTuber. We're gonna get there. But okay, so everyone do a big stretch into the air. You can do to the left side. Ooh, stretchy. To the right side. Yeah, stretches. Okay, and then we're gonna stretch up. And then we're gonna stretch down. Touch your toes if you can. I can't touch my toes, but if you can, touch those dogs. Okay. Wow. I feel so much better. Alright, Go Shujin-sama, as promised, now that we have finished this singular problem 4 hours later, wow, in C. Thank you so much, chat. Thank you, Go Shujin-sama, for helping me through that. I could not have done it by myself, truly. Maybe next stream you can do a problem in the B language. Alright, all right. Some quick Megane Midori lore. For those of you who have followed me since my 5.1 play days, you will know this. That I believe it was for a charity stream. The bit for the stream was that for every bit donated, I believe it was, or I think it was every bit donated, I would read another word of the B movie script. And I also did this when I was playing Celeste, which was that every time I died, I think it was every time for every death, I would read that far into the B movie script, and I ended up having to read, like, multiple times over. As Vision-sama remembers the B movie script. Yeah, so I ended up having to read the B movie script entirely from start to end, like 3 times. I read it, like, once or twice, and then Sidki-sama, I believe, actually came on and, like, got FOMO and actually did, like, a reading themselves, because I was having so much fun reading the entire B movie script. So yeah, we gotta do it in B-lang next. Where, it's an SO-lang where every syntax, like, all the syntax is, like, words from the B movie script. Also another maid, yeah, was it Ruka that got in on that? Like, I roped so many people into reading the entire B movie script live on stream. Oh my gosh. Okay, here's what I'm gonna do, Goshujin-sama. I am going to go, pet a cat for about 30 seconds, and then I'm gonna come back and post cat pictures on the Discord. I'm gonna pull it up on my computer, and I am going to tell you Midori's very exciting cat story. I promise you it was worth the wait. Thank you so much, Goshujin-sama, for coming with me on this long journey. I'm going to BRB, real quick. Stick around, because you do not want to miss the cat reveal, Midori cat reveal. Alright. 少々お待ちください、ご主人様. I'll be right back. Alright, Go Shujin sama. It is time. It is time for the long awaited cat story. Let me, unfortunately, I should have gotten like pictures ready, but I'm gonna just kind of like post and pull up pictures. I'm just gonna kind of post pictures as I tell the story, alright, and pull them up. So, this story begins several years ago, actually at this point, like, I would say many years ago, when we first, moved into our current living arrangement. There were a couple of cats living in our front yard. So at the time, there were two really cute cats, named Silver, one named Silver and one named Cashmere. Silver was like a very small but scrappy gray cat. She kind of like owned the neighborhood. And then the other cat, her name was Cashmere, and she's like a big fluffy black cat. She's very, very cute, but very, very, very skittish. Okay, and for the longest time, those were the only two cats in our front yard, were those two, and we were feeding them, and we were getting closer to them. Silver particularly was very food motivated and very brave. So we started bonding with her, and we were able to get closer to her, but she never got over her like fight instinct. So even though she really liked our food and she liked being close to us, she wouldn't let us actually touch her or anything, or she would bite and scratch. Red Hot Maki-sama, o kaeri nasai mase, go shujin-sama, welcome to the computer lab. You have come just in time for the cat story. I'm trying to pull up some pictures of these outdoor cats. I wonder if I have... let me pull up a good one. Of Moya as on our porch from a little while ago. Where is somewhere that I would have posted this? Maybe in this server I can find a good picture of her from back then. Oh, well, here's a good one of Moya, of Silver and Cashmere. So I'll post this picture. Okay. There we go. I'll post that in the Discord, and then I will pull that up in my browser. And pull that over here into my browser. Okay. Now we have cats. Alright, so this is Cashmere and Silver. Like I said, Silver was much more brave, and so we always got to spend time with her, and she would eat like right at our feet, but we could never touch her because she always she had a very strong fight reaction. Whenever anything happened, she had like a very strong reflex to basically swat at anything that came near her, especially her face. So we never really got to touch her, but we loved Silver so much. And then Cashmere was kind of like her shadow. Like for a long time, we saw barely any of Cashmere. She would be like always like a couple feet away from Silver, but never like showing her face to us. We would put out food, and then as soon as we walked away, she would come out and eat the food, but she would never eat it in front of us for a long time. Yes, hello, Silver, hello. Until like a year later, maybe, she finally like started getting a little closer to us, and a little closer to us, and a little closer to us. And we thought that because Silver was so like brave and kind of like derpy in a lot of ways, like she was a very silly cat, and so whenever we saw Cashmere, we thought like, oh, she's like Silver's brave protector. She must be like the strong silent type, right? But then as soon as Cashmere started showing her face around us, we were like, oh wait, she's dumb. She's really dumb. TypeScript and LeetCode, when did PrimeGen start VTubing with a voice changer? I don't know who PrimeGen is, but maybe I should check them out. You've actually El Cholo-sama, you've actually joined us at the very end of my stream. So we've kind of wrapped up our leak codes, which I was doing in C, because one of my Go Shujin-sama decided to cash in a language change, so I did it all in C. But I am doing some life updates, featuring some of my lovely outdoor kitties, the stray cats that we take care of in our neighborhood. Yes, so Kashmir started showing her face around us, and we found out that she is not like the strong silent type. She is just really dumb. She's got like nothing going on between those ears. And so she's just really, really skittish. So she started like getting closer to us and getting a little closer to us, but she still wouldn't, like, neither of them would let us touch them. Silver was like, an orange cat in a silver coat was definitely like Silver's energy. She had a very strong fight response, whereas Kashmir had a very, very strong flight response. So if we got anywhere near touching her, she would just bolt away. Right? Okay, so some time passed, and a third cat hit the scene. So we didn't know she existed for the longest time, because she was so skittish that she wasn't even, like, around. But she started showing up a little more and more. Let me find the picture of her that I am looking for. Where'd it go? I have a really good picture of her eating, like, tuna. I didn't post it in this chat? How could I have not posted it in this chat? It was such a good cat picture. Okay, I know the chat that I can find it in. One moment, Go Shujin-sama. I promise that it's worth it. I promise it's worth it. Go to this pet pics and find from me has image. Okay. Okay, I can't find the exact one I'm looking for, but this one does a good job at representing who this cat is as a person. Let me save that picture, and then I'll post it. Okay, and then I can pull it up. Pull that over here. Okay, so this is the third cat that hit the scene. Her name is Moya. So actually our neighbor named all of these cats because she takes care of all the feral cats in the neighborhood. She does like trap, neuter, release, which is really, really, really good for our neighborhood, because our neighborhood kind of has an infestation of feral cats. To be honest. So, our neighbor does trap, neuter, release, and, she feeds, she puts out food for the local cats, and she names, like, all of the cats that she sees. So she actually named her Moira, but I misunderstood, like, I misheard, and thought she said Moya for the longest time, and by the time I found out that her name is actually Moira, she was already Moya to me. And I think she's more of a Moya than a Moira, which you'll see why in a little while. But she is really gorgeous. They're all really gorgeous. She is even dumber. She's even dumber than Kashmir. I don't know how, but she really had nothing going on between those ears. Like, you can see in this picture, she's like, I'm pretty sure that this wasn't even like mid scratch. Like, she just kind of stopped scratching herself with her leg up there and just started like staring into the distance. And you can see that her fur is like so long but so like thin that when she grooms herself, her like fur gets stuck in her mouth, so she's just walking around with like a little beard, a little like tuft of fur sticking out of her mouth. It's the cutest thing. She looks so dumb. Yeah, so this is Moya. So Moya was even more dumb and even more skittish than Kashmir, so it took a long time for her to get anywhere near us, for her to even show her face. But when I saw her, because she looks kind of like a ragdoll cat, and I know ragdoll cats are like really cuddly and really friendly. So I was like, okay, I don't think that Silver is ever going to, like, I think that Silver wants us to pet her, but I don't think that she's ever going to get past her, like, fight response to let us pet her. Like, Cashmere actually, like, lived in my neighbor's house for a little while, and she never accepted human touch. So I was like, I don't think she's ever gonna let us pet her. But this cat is gonna let us pet her. I just know it. I can feel it in my bones. And after just a little while, we finally got close enough to pet her, and, like, as soon as we made contact, she was like, oh yes, this, more of this, please. So basically from that day forward, she would come running up to our porch, begging us for pets, just begging us for pets, like every single day. So we've gotten more and more close with Moya, over the years. Since then, we've gotten much more close with her. We feed her every day. We, like, pet and cuddle with her every day. And recently she's kind of been, like, disappearing for a couple of days and then, like, showing up again. And we're like, oh, what's with that? And, she actually, okay, two prongs of this story. Okay, I'll continue talking about Moya, then we'll get back to Cashmere. So Moya kept kind of disappearing, and then most recently she disappeared for a couple of days, and she showed up with, like, a huge hole in her face. Just, like, massive gash. Like, she clearly got into some kind of fight. We were really worried about her. And for a couple of days, we were like, okay, she's an outdoor cat. She's pretty old. We know she's at least 16 years old, because we have a picture of her from 16 years ago now, like, in our yard, like, looking like an adult cat. So she's clearly, like, over 16 years old. Like, she's been in the neighborhood. Like, she knows how to take care of herself. We're gonna trust you, Moya, to take care of yourself. And then every day after that, she'd come up, and her wound was just getting, like, bigger. It was, like, gross. It was not good. So we were like, okay, we have to do something about this cat. So yeah, it was like a hole. Like, when we saw it, it was too bloody and, like, matted for us to really tell, but, like, once it got cleaned out of the vet, it was literally, like, a chunk. Like, a whole, like, nickel-sized chunk taken out of her face. It was really bad. I felt so bad for this poor baby. So, yeah, eventually we decided that, we need to take her into the vet, because we were worried that it wasn't healing properly. You know, we were worried about it getting infected and things like that. So we took her to the vet, thankfully, because we had built up such a relationship with her, it was actually not hard to get her into the cat carrier. We literally just, like, my server admin just, like, scruffed her, and we just put her right in. I botched it a little bit, so we did get a little scratched up because I was a little too slow to close the carrier, but, like, overall it went very smoothly. She's, like, a very, like, malleable cat for being, like, out in the wild all this time. So we take her to the vet. We spend an ungodly amount of money on vet bills. We find out in the process that she is microchipped. She has a chip. We're like, what? So, you know, all this time my friends would come over, they'd be like, oh, she's so pretty, there's no way that that's, like, a feral cat. Like, that definitely used to belong to someone. Like, that's like an escaped house cat. And we're like, no, I think she's just, like, a really pretty feral cat, but it seems like maybe she did belong to someone once. And I don't know if she, like, ran away and got lost, or, like, God forbid someone abandoned her. I don't know. I don't know what happened in her past, but she's been in our yard for 15 years. She's chipped, and her chip is not, like, registered to anyone. So, yeah, that was, like, a shocker. That was, like, a big surprise. I felt like I was in a, I felt like I was in, like, a soap opera, and, like, finding out that, like, my child, like, isn't mine. You know? Like, one of those big, like, dramatic reveals. But no, she is ours. She's definitely ours. Yeah, when she first started showing up, she was really ratty, like, pretty thin. Her fur was like almost had patches missing, like very, very thin fur, like totally naked belly, you know? But yeah, since we've been taking care of her, she's like really fluffed out and like started like getting very cuddly and very friendly. And with us, she's still very nervous around other people, but with us, very like friendly, very cuddly. So, okay, so we brought her to the vet and we took her in and we spent like several $1,000s getting her stitches and everything. And we're like, okay, I guess she's our cat now. So, obviously we had to keep Moya indoors, because, all right, time for the next picture in the story. Let me pull up my files and find a good picture. What's a good cute one of her looking real dumb? Okay, here's one like at the vet, so I'll show that one. Because she is now, open this up, she is now in her little dunce cap. She has to wear a cone now while her stitches are healing. And I took this from an angle so you can't really see it, just because I didn't want to flashbang you with like cat gore, but she has like a pretty gnarly stitches on her cheek now, so while it's healing she has to be in the cone. She has to wear her dunce cap and she looks so silly in it. The poor little bitch. She went from a feral cat to being a house cat in a cone. What a 180 this poor baby has taken. What a change in lifestyle. So yeah, so we have to keep her inside, obviously, while she's in the cone, while she's healing, so that we can keep an eye on her and give her pain medicine and everything. She learned to use tools. It's true. Yeah, now that she's inside, we're kind of wondering if she's like smarter than we thought she was. Because she's figured out already how to like scoop. Like, it's hard to eat out of a bowl when you're a cat with like a cone on. So she's figured out how to scoop the food like into her cone and then tilt her head back so it like slides into her mouth. She's making the best of it. She's like the most happiest cat I've ever seen, having to go through all of these changes and all of this like pain and still like she's been through so much, and yet she is still like cuddling with us and purring and headbutts and like, you know, making the best of her situation. Like, she is an extremely resilient cat. But yeah, so we have to keep her inside for at least like a week and a half, and we spent like several $1,000s on her, so we're like, okay, I think she's lost her outside privileges. I don't think she's ever going outside again at this point. So we put her in a small bathroom for the first night, and she wasn't exactly happy, but she's dealing with it, and it took a couple days because she was clearly very stressed, even though, you know, she's still purring with us when we pet her. Like, she's still friendly with us, she still loves us, but she was clearly very stressed. Like, even now her tail is like permanently like in between her legs. Like, she's still very stressed out, to the point that like for the first couple of nights that she was in here, she didn't like eat really anything. Like, she'd eat like 1 or 2 treats if we hand fed her, but she wouldn't eat on her own, and after like treat number 2 or 3 she'd like even stop eating the treats. She'd eat churros, but like she wouldn't eat like her dry food or anything like that, and she wasn't drinking any water, which we were really worried about. But yesterday I decided to let her out of the bathroom because it seemed like being in there was like stressing her out more. The hope was that it was a small place where she could like chill, but it seemed like she was getting really antsy to get out of the bathroom because we showed her around the house a little bit more, and she was like curious, but she also got really stressed out. So we put her back in the bathroom, and then she seemed to be getting even more stressed out. So I kind of like partitioned the house so that she can be in like the front half of the house with the bathroom door open, because it seems like even already like she's identified the bathroom as like her safe space. So anytime she gets anytime she gets stressed out, she like runs straight back to the bathroom, which is great. Because it means that there's a place that she feels like relatively safe. But I left the door open last night, and I slept like on the floor next to the bathroom with her, and I let her out, and you know, she's still like scratching at the front door periodically, like remembering that she is an outdoor cat and wanting to go outside. But actually, like a couple minutes after I opened the bathroom door and let her just do her thing, like she immediately started drinking water. She's like eating all her food now, cleaning her bowl. The only thing, she hasn't pooped yet. She has not pooped yet. So that's like the last, I feel like once she poops, I'm gonna be like, okay, she can be an indoor cat, you know? Like, she is using the litter box. She hasn't like peed anywhere, but she still hasn't pooped yet. Probably because she only just started eating again like today. So I'm like, once she poops here, then she's ours. I don't know if any other cat, if that's just like a cat person thing, but like, you know, you want to make sure that your cat is drinking water, eating food, and pooping. And as long as those things are like good, then you're like good to go. Not an outdoor cat anymore. Sucks to sucks. Maybe don't lose fights that badly, idiot. Exactly. So yes, this is Moya, our new indoor cat. I actually put it on my like goals, my New Year's resolutions. I didn't do resolutions, but I did like a bingo card of goals that I wanted. And I was like, okay, one of my bingo items is making Moya an indoor cat. And Siki was like, that's not gonna happen. And I was like, I know, but I'm just gonna put it on my bingo card and like see what happens. You know, like manifesting. So, let me find one more cute Moya pic, if I can. Here, I have one of her cuddling with us. Actually, let me get the one that Siki-sama sent me. She is newly learning about beds. She's learning what beds are. And part of me, like, I wonder how much of this is her, like, remembering her past life as an indoor cat, you know? This is a good one. This is a really good one. Let me post this. You can kind of see how scrungly she is in this one. Alright. Last Moya pic of the story. Here is her learning what beds are. She actually spent the majority of this stream, laying in bed, next to Siki-sama, and, just purring and, cuddling and being really happy. But yeah, this is her, I think, last night, with her almost naked. She's got, like, such a dumb pink belly. It's so cute, and it's so soft. And I don't know if it's just because with the cones she can't, like, scratch herself or, like, groom herself, but she is, like, totally amenable to belly rubs. Like, she is a belly rub cat right now. I don't know if this is still gonna be true, like, later on when she gets the cone off, she can groom herself, you know, when she's not on, like, opioids all the time, because we are giving her, like, pretty strong pain meds still. But yeah, she's just the sweetest, goodest cat, and I look at her and, like, knowing that she, like, belonged to someone and they lost her or something, I'm like, I can't imagine, like, those poor people, like, losing such a good cat. She is a grade A cat. She's a perfect cat. Let's see. You can take the cat out of the streets, but you can't take the streets out of the cat. You would think so, but, like, looking at how she's adapting to house life so far, like, knock on wood, maybe it'll get harder, like, once she realizes she's really never going back out. But, like, so far, like, you would never have even known that she was a feral cat. Like, even with the vest, she was so good. Like, oh, she's such a good cat. I love her so much. That cat knew that she's gonna get a lifetime supply of kibble and excellent living conditions once you started to pet her. I know, right? I know, right? El Chillo says, I'm gonna have to stop dilly-dallying. A VTuber knows two statically typed languages and does LeetCode. Meanwhile, I'm holding on for my dear life trying to get the gold badge for Python and hacker rank. You'll get there for sure, especially if you keep showing up and doing algorithm problems with us. Okay, so that is the Moya story. That is our new cat, Moya. She's kind of been our cat all along, but now it's, like, official that she is our cat, and I'm so so excited about this cat. I love this cat so much. Okay, no more dumb voices. The other, like, part to the story is, so Silver actually passed away a couple of years ago, which was really, really sad, because she was, like, she was kind of my favorite cat at the time. This was before, like, Moya had gotten more close to us and everything, so, you know, but at the time, Silver was definitely, like, far and above, like, our favorite cat, so it was really, really heartbreaking to, like, see her go, but, Kashmir, has also been getting closer to us, and actually, a while after we started, like, petting Moya all the time, all of a sudden one day, like, Kashmir came around on it, and we're now, like, petting Kashmir too, and Kashmir is, like, not only letting us touch her, but, like, really, like, coming up to us for pets, and letting us pet her even when we're not giving her food, and, like, purring, and we were able to, like, get, like, all the mats out of her fur, because she's got, like, really thick, long fur, and so her fur was, like, very matted, so we were able to, like, cut out, like, almost all the mats, so she's now, like, got, like, smooth fur, she feels so much better, and, like, her personality also changed instantly, like, she used to come up and, like, hit Moya out of nowhere, like, we'd be... Yes, I am vastly understating the effort and patience needed with Kashmir. This was, like, many, many years long effort, and, like, not even inch by inch, like, centimeter by centimeter of progress with this cat. I didn't think it was ever gonna happen. So when she suddenly started letting us pet her, it was, like, crazy. And, like, around that time, like, her whole personality did a complete 180. Like, before that, we would be petting Moya, and Kashmir would come out of nowhere and just hit her, and, like, hiss at her, and we're like, dude, what is your problem? And ever since then, like, when we're petting Moya, like, Kashmir will come up and, like, headbutt her, and, like, nuzzle her, and then Moya will start, like, cleaning her, like, licking her, so... Yeah, so, now every time I go outside and I see Kashmir lounging in our front yard, I just go, you're next! Did you know? Did you know, Kashmir? You're next! So, yeah, and not for a while, not until, like, Moya has, like, fully adjusted to indoor life, because I think having them both adjusting at the same time would probably cause, like, extra stress on both of them, but... Yeah, I think once Moya has fully adapted to indoor living, that's my next bucket list item is getting Kashmir to come inside too. So yeah, that is my fun cat story. I hope you all enjoyed. I hope you all enjoyed getting to see my cats and getting to see me struggle through the C programming language. You know, I think I understand it a lot better now. Thanks to everyone. Thanks to everyone. Worth it to stay up until 1:15. Thank you so much for sticking with us till the end. Wonder Bread Sama, thank you so much. The C stands for struggle. Exactly. Okay, so, really quick stream updates, and, I'm going to see who to raid. Next, LeetCode and Rust. I would be totally down for that. I've always wanted to learn Rust. I would love an excuse to learn it. I am going to go ahead and pick who we're going to raid first. Oh, Sickfall Sama, thank you so much for the subscription. Welcome to the Cursor Club. Thank you so much. Oh, Coffeetron is playing Big Walk. Perfect. Okay, I don't know who was here last week, but last week I accidentally ended up raiding into something I didn't mean to raid into. I raided into KK Cyber, the legend KK Cyber, who I do love. I love KK Cyber. But I did not realize that she was doing an ASMR stream at the time that I raided her last time. So I have learned a valuable lesson to always check before I raid. But, yeah, the ASMR raid was not a look I would like to repeat. No offense to absolutely anybody. But, okay, Coffeetron is streaming Big Walk, and I think that seems like a really great thing to raid into. So, that's who we're gonna raid. I'm trying to think if I have any quick stream updates before I go. One thing is that I decided that the next stream update that I'm gonna do with my donations is going to be, you're saying we can't language request for ASMR. You know, I'm gonna have to think on that one. I am definitely not an ASMR streamer, so I am not personally gonna do an ASMR coding stream. I would have to think on that one. At the Rust Missionary, so what is your favorite language? The Rust Missionary, Sama o kaeri nasai mase, go suji sama, welcome to the computer lab. You have unfortunately joined me right as I'm ending my stream. But we are about to raid out into some really fun other coding VTubers who are currently playing Big Walk. So I hope you do enjoy that. I have decided that the next mini goal for my stream updates with the donations that I receive is going to be an anime profile picture. So I've picked out a couple of artists on VGen who do profile pictures, and I think it's looking like about $30 for the person that I'm currently looking at. So we may have reached that tonight with all of these subscriptions. I'll have to check. So keep up to date on that. You can follow me on my Coffee if you want to watch updates on that kind of thing. Thank you so much for the follow, the Rust Missionary sama. Okaeri nasai mase, Gosujin sama, welcome. Yeah, you can follow updates on my commissions status and stuff on Coffee. And the status for the emotes is we are still waiting. It was about a 3 to 4 week, I think, period for them to complete the commission, so it'll still be a couple weeks till we get those in, but those are on the way. Next stream is probably going to be Thursday. I may or may not do an off stream during the week if it's a little bit calmer than it was last week with all the vet visits. But definitely Thursday at my usual time, I'm going to be streaming LeetCode again. We will continue on to the next section of linked lists. Maybe it'll be in Rust. Maybe it'll be in something else. Thank you so much for the tip! Oh my gosh, Bread-sama, thank you so much! We reached our donation goal, so I will go and get my profile picture request in right away then with the now funded the funded goal. So yay, thank you so much. Probably not a great idea to write a linked list in Rust. Okay. Well, maybe I should come prepared in case somebody decides to do that to me again. It's like the classic don't do this example. Oh no. Oh no. Okay, good to know. It's fine, don't worry. Alright, I will... I might worry a little bit. Anyways, with all that being said, I think we are going to raid out into Coffeetron right now. Thank you all so much for your support, for watching me suffer through. I hope you enjoyed watching me suffer at least a little bit. Let me go into... Oh, I have it right here. I'm gonna go ahead and start that raid. Oh, he just went offline! No! Okay, let's see who else is streaming. It looks like Shindigs is streaming. Let me make sure that Shindigs isn't doing ASMR. Godot stream, adding new spawn animations and avatar features. Okay, that looks pretty fun. Alright, let's raid into Shindigs instead. Open source BTW, yes, I love Shindigs. Open source BTW, okay, and, you know, we haven't had, like, a raid, what is it, like a raid message yet, but I think I want our raid message to be, let's see, green heart emoji. Let me copy and paste this. Okay, I think I want our raid message to be Tadaima. Yeah, so if everyone can raid with Tadaima, with green hearts, that would really make me super happy. It's a little basic, but I feel like it encapsulates what we do here. So, with that being said, I'm gonna go ahead and start the raid. I'm gonna cut to a BRB while it's loading, and yeah, thank you again so much. Thank you. Let me go ahead and someday I'm gonna get smoother at this whole raid thing. But let me click on raid channel and then go to search and filter Shindigs. Great. I'm gonna go ahead and start the raid and then switch over to my stream ending. And yeah, stick around for Shindigs. He is super, super cool. I think you'll really like him. He is not doing ASMR. So yeah, I'm gonna go ahead and click start raid. And yeah, enjoy. Thank you so much, and I will see you next time. Until then, いってらっしゃいませ、ご主人様. I'll see you next week. Bye bye. Thank you so much.